All right. So today we'll start our 3-week series on data interpretation and research translation. So just set the expectations right. This session is not about writing code. We're not going to be writing code or doing anything of that nature. Rather, the emphasis is on how do we actually interpret the outputs from data. So it's going to be a 3-week series. Today we'll focus on descriptive statistics. Next week we'll focus on bivariate analysis, and then the upper week we'll talk about regressions. And so it builds on each other successively like that. So some things we need to understand clearly so we are all on the same page. Data, information are not the same thing. Data refers to raw facts, right? And then when we put context, when we now put context around data, we have information. That's why we say that AI cannot interpret data accurately 100% of the time, because some of that context you need might be only in your head, right? So you need to take out that context from your head, add it to the data, and that's what gives you information. So information is simply data plus context. Now, knowledge is information plus understanding. Take note that it's not just about assimilation, but we need to understand for us to say there is knowledge creation. So when you say that your study aims to fill the gap in knowledge, you are implying that you're not just going to throw out some data, but you're going to translate that data for us in a way that we can understand. Hence, the focus of this webinar, right? It's about how do we generate knowledge, not how do we generate data, right? And that means that we should be able to take that data, add some context to it, and then interpret it in ways that folks can understand. And most importantly, the end goal is to move the needle on something important, right? Maybe policy. For those of us who are in public health, that's the highest level of impact you can have when your research findings inform policy change. So to give an example, so many years ago, we got at CDC, we received letters from several commissioners of health in some states. Oh, smoking in airports is a bad thing. We need to really address this. Of course, we need to do evidence-based policies. And so what did we do? Well, we deployed to the field to collect data, went to all the airports with smoking rooms and some control airports without smoking rooms, and measured levels of particulate matter, right? So all we're doing here is just data collection, nothing more, nothing less. That's just plain old data. Now, we take that data and interpret it and say, oh, you have high levels. You see that in areas where there's smoking, you see high levels of particulate matter that could cause health injury, respiratory health issues. And so this is now translating this information in ways that the people who need to hear this and understand it can hear and understand. Now, who needs to hear and understand? Well, policymakers, you have journalists, you have the lay audience, the population in general. They need to be educated about their risks, And so it's not just about taking the data and dumping it on them. It's about how do you craft the message in ways that everybody can understand. And then ultimately, well, the impact of the work is, well, the airports realize that, oh, this is a major hazard. And so all the airports, most of them shut their smoking rooms. Now, this will not happen if we do not collect meaningful data, and obviously if we do not convey that information in ways that people can understand. The people who need to take action can understand and take the necessary action. So the whole point of this series, this 3-week series, is talk about how do you convey information in ways that are meaningful, right? And what are some of the principles that we must adhere to when we are translating information to policymakers? Now, we also need to understand the clear difference between, by the way, if I'm looking at another direction, that's because I have 2 screens. So don't be wondering why I'm looking away. We need to also understand the difference between research translation and translational research. Those are not the same things. Sorry, hold on a minute. Let me mute my phone. All right, so very different things. They sound similar, but they're very different. Translational research is about how do we create products or tools from basic research. So we start from basic research, preclinical research, and then we build on that to animal studies, to human studies, to to population research, right? That whole cycle is what we call translational research. So in other words, we're translating findings we got from basic science in a way that allows us to innovate and create products or medicines that will serve population. So we start from a cell and we end up in a population. That's what we call translational research. Research translation, however, is different. It means at each stage of this cycle, how do we take the findings we have gotten and convey them in a way that other people can understand? So it's about making it make sense to other people, not just to us. So think of it that when you're translating a document from English to Chinese or vice versa, right? That's the exact same thing we're trying to do with our research. Take it in a way that is dense and built for scientists and conveys in a way that is more meaningful that everybody can understand. So that's what we mean by research translation. So everybody who does research should be an expert in research translation, because you're not just producing the results for producing sake. You want those results to have an impact. And for them to have an impact, it's not enough to just dump the data on people. You have to translate the results in a way that others can understand what you're saying. So let's look at some basic do's and don'ts of research translation. Number one, simplicity. Simplicity, as Da Vinci says, is the utmost sophistication. The goal of conveying any information is never to impress. So if you're just trying to impress other people, well, you've already started on the wrong foot. The goal is always to communicate. Why waste people's time if you're just trying to grandstand? No, that makes no sense. So the goal is to communicate, not to impress. You should always have a clear SOCO. SOCO stands for Single Overriding Health Communication Objective. You don't want to be all over the place and say, oh, smoking is, we have found high levels of particulate matter, and then we saw people who were putting trash over there. No, you have to have one single communication message, right? And for those of you who do media, who speak for your organization, this is a very important part of media training. Because when you speak with the media, they always try to get some juicy sound bites from you. So they will say at the end of the day, oh, CDC was surprised that this happened. No. So whatever the media asks, you always have to find a way of coming back to your SOCO, right? Whatever the question that was asked, well, this is the bottom line of what we're trying to say, that X and Y, whatever the relationship you're trying to explore, whatever the message you're trying to convey. So you need to have a clear communication objective and not be all over the place. You also have to understand that there's a trade-off between scientific precision and clarity of the message to a lay audience. That means that whenever you're communicating with audiences that are not scientists, something has to give off. You have to give up something. You cannot maintain the same high technical language and still be clear. So sometimes you have to sacrifice precision of language to make it clear. So it's a trade-off. It's always a trade-off. Okay, how much precision do we want to sacrifice on the altar of clarity? But that's something that you must make, because otherwise nobody will understand what you're saying. Again, remember, the goal is not to impress, but to communicate. And less is more. This is very, very important, especially when communicating with policymakers who are very busy, or with journalists, right, who have very limited space to write anything that you're trying to tell them. Or even if you're just trying to post something on LinkedIn or wherever, right? It's the goal is to water down what you're saying today, the most, distill to the most important points that others can learn. It's not to pass everything to them. Of course, you may have done a lot of research, but we're not necessarily interested in reading about everything you research. We just want the key points. So always remember that less is more. Now, what are some don'ts? Don't extrapolate. Extrapolation is when you go way beyond your data. So you collect data on today's outcome, but you're predicting for tomorrow's event, right? No, don't. So if you collected data on smoking between 2000 and 2010, well, just tell us about events from 2000 to 2010. Don't tell us that based on this data, we can estimate that in 2050, there'll be 50 million smokers or 50 million people will die. That's what we mean by extrapolation. You are going beyond your data to make grand statements that are not necessarily based on the data scope. That is not good. So don't extrapolate. Don't sensationalize. Your findings found X, Y, and Z, but here you are saying that these findings will cure HIV, will end hunger. or bring about world peace, right? Just stay within the findings, and that's fine. Don't speculate. Speculation is very common in research when people already have something in mind they want to say, and regardless of what the findings show, they still go ahead and say whatever they wanted to say. And that's speculation. And then don't be a contortionist. There are several ways in which people contort themselves, especially when it comes to reporting of p-values. We'll talk a lot about p-values next week, but here are just some few examples of just very contortionist kind of statements. Statements like our findings attained borderline significance. Statistical significance is like pregnancy. You are either pregnant or not. There is no such thing as borderline significance or almost significance or results being shy of significance or minor significance, whatever that means, or marginally significant significance. That is the tongue twister. Or being tantalizingly close to significance. All of that is just garbage, right? So we don't want to contort our findings to say, oh, we almost got it when we did not. That just defeats the whole point of research. Next week, we'll focus a lot about p-values, what they are, how to interpret them. But the point we're trying to make now is that we want to stay within the lane we have and not go beyond that, because that is not just ethical in terms of scientific publishing or ethics. So, like we said earlier, 3 weeks, which we're going to map according to the order in which we develop research. We start from descriptive today. So today we'll talk about percentages, we'll talk about confidence intervals, we'll talk about means and standard deviations. Those sound simple, but if we don't understand them very, 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 very well, then we don't understand all of research, because those are the foundations of research. So we'll talk about how to interpret them correctly today. Next week, we'll focus on just 2 big items: p-values and how to interpret results from bivariate tests like chi-square tests or 2-sample t-test and all of that. And then in the 3rd week, we'll focus on how do we interpret results from multivariable analysis like logistic regression and linear regression and all of that. Very importantly, something people get wrong a lot: how do you interpret results from interactions? You might have some interaction terms in your regression. How are you supposed to interpret them correctly? And also something that people get wrong a lot: how do you interpret results from log transformed outcomes? So sure, you were doing your regression and you found that it was not normal, so you did a log transformation. How are you supposed to interpret that? Obviously, you're not going to interpret it the same way as if it was not log transformed. The interpretation changes completely. So we're going to focus on that in 3 weeks. So, but today, like I said, we'll focus on the basics, the foundational aspects, descriptive statistics. Now, this is the most important slide of all the slides we're presenting, because it is very important for us to understand this slide, to understand anything about research and why we do the things we do. So it is not enough for us to just do certain things because we've heard that this is how it is done. We need to have a foundational understanding of why we do things a certain way in research. And for us to understand all of those things, we need to understand first that there are 3 things that explain any phenomenon in the world. Just 3 things. Anything you observe in the world can be explained by one of 3 things. That is truth, chance, or bias. The whole point of research is to find out the truth. But we cannot find out the truth without having to deal with chance and without having to do with bias. So all of research, all the 1,000,001 things we've heard about in research is all about extracting the truth from bias and chance, right? How do we control for chance, which is where p-value comes in? We'll talk about that next week. But p-value is all about controlling for chance. How do we control for bias? This is where regression comes in, right? Why are we doing regression? What does it even mean? Well, we're trying to control for bias, right? The whole point is to extract the truth, right? But if we don't understand the big picture of why we're doing it, then it's a moot point. So this is why this is the most important slide, because it forms the basis for everything we do, everything we talk about. And the question, of course, is what is truth, right? Truth is truth absolute or is it relative? Well, in the context of research, we hold that truth is relative. So again, relative to what? That's some of the things we're going to discuss, but we need to have a very clear understanding of this slide for us to understand every other thing we're going to talk about during the series. So let's look at an example of those three phenomena. Truth, chance, or bias. You get a 95% in the test. Well, what are the possible explanations? One is that you're really smart and you understood the material and you deserve that score. Well, but it's also possible that it's just by chance. You guessed, you somehow are super lucky and you guessed all the correct answers and you got a great score. That's chance. It could also be biased, that the test was written in a way that favored topics you studied, or that you cheated on the test, right? Again, truth, chance, or bias, that explains every single thing. On the population level too, it's the same thing. A study found that students who studied for a test perform better than those who did not study. Well, truth, chance, or bias. It could be that the amount of study is truly associated with test performance. That could be true. But it could also be chance, that the difference we saw was just purely by chance. But it could also be bias, because it could be that students who study longer come from very stable homes, or homes where the parents are overachievers and the parents are really making them study, and the parents are also bringing in extra tutors. So it's not necessarily because of their study time per se, but it's because of external influences that are related to study time. That's what bias is. So we need to understand fundamentally that every single thing in the universe we see and observe boils down to one or more of those three things: truth, chance, or bias. And that is the whole reason why we do research, to extract the truth from the clutches of bias and chance. All right, so the first thing for today in terms of interpretation is percentages. So let's dive into that. So let's start by asking ourselves the difference between a percentage, a proportion, and a prevalence. Well, let's talk about percentage first. A percentage is like a tape rule. I call them tape rule measures, right? A tape rule doesn't care what it's being used to measure. You can use a tape rule to measure the length of a door or the length of a window or your height. It's agnostic to, what is being measured. It doesn't really matter. It's agnostic to it. That's exactly what percentages are. Percentages are tape rule measures. They don't care what they are being used to measure. So you can use a percentage to measure incidence. You can use it to measure prevalence. You can use it to measure any other thing. So we need to understand that one is a rule, the other one is what is being measured. So percentages can be used to measure things. And this is where context, remember we said the difference between data and information, and why AI cannot interpret your data. Imagine you just gave me a number like 50% of people smoked. Now, sure, my next question is that, okay, what kind of measure is that? Is that incidence? Is that prevalence? There is no way I or any other person or AI can know what that means without context. You are the one who designed the study. You are the one who measured it. You are the only one who can tell us whether that percentage we are reading represents a percentage, represents a prevalence or an incidence or any other metric, right? It is impossible for any other person to know. So once again, just emphasizing why context is important, because without context, the data is kind of useless, because we cannot make any sense of that data without you bringing additional context and giving it life. So that's the difference between a percentage and prevalence. Percentage is a tape rule measure that can measure anything. It can be used to measure incidence or prevalence. And prevalence obviously represents the burden of whatever it is we're trying to measure. Now, what's the difference between a percentage and a proportion? Well, it's potato, really. They are just scaled differently. It's like saying 100 cents versus $1, right? 100 cents make up it $1. So it's the same thing with proportions and prevalence. It's the scale that differs. A proportion ranges from 0 to 1. A percentage ranges from 0 to 100. So if I'm expressing half, I can say call half as 50%. That is a percentage. Or I can express half as 0.5, which is a proportion. Now, here are some misconceptions people have about proportion, which we should make sure we don't fall into that trap. Some people imagine that proportion means a subset of a population, that if you're talking about the whole population, you use percentage. And if you're referring to a subset, you use proportion. That's false. They are one and the same. The only difference is the scale of measurement. we also have to be, it should be clear from here also that a prevalence is not a rate, right? Prevalence is just a unitless measure. Rates involve time. So whenever there's an added element of time, we'll talk about rates. So please do not say statements like the prevalence rate of smoking was 50%. Like that makes no sense whatsoever. You are literally reinventing epidemiology. So that does not exist. So just say prevalence, and that's fine. Also, try to avoid just saying percentage. That's the point we're trying to make, because percentage doesn't give us any clear context of what it is. So instead of saying the percentage of smokers was 50%, why don't you just say the prevalence of smoking, if that is prevalence indeed, was 50%? Because now that gives us so much information that we will otherwise not have gotten if you had just left it as percentage, because it's really, really lacking context in that way. And we'll look at practical examples in a minute. We're just trying to make sure we understand some basic principles so that we're all speaking the same language. Let's also understand the difference between standard deviation and standard error. Both of them are measuring variability, but they measure different aspects of it. So here, you can see that standard deviation has to do with individuals, while standard error has to do with populations. So if I gave all of us, let's say if I ask how much money all of us have in our pockets right now, and we took the average of it, I would say, okay, how many dollars does each person stray away from the mean, right? And we take the average of all those deviations. That is the standard deviation. We're talking about individuals. We as individuals, how we vary around the mean. So that's standard deviation. Now, for standard error, we're talking about populations. We're not saying you, and you. We're saying, what if we took this population and that population, and we'll see for each population how
So
far...
sorry, Prof. I'm so sorry, Prof. I'm so sorry, Prof, to disturb. I just want to ask those who are drawing lines, please, can you stop? Everyone who's using the annotation feature, can you stop using it, because you're drawing lines on the screen and it's quite distracting, please. Thank you. Sorry, Prof, you can continue.
No, you have to continue now. All right, sure. So someone didn't get the memo. I just saw a brand new line.
Gregory, please stop.
All right. Do I have to restart the screen, or it can be cleared? Okay. All right, I'll just continue. All right, so what was I saying? Okay, the standard error has to do with population. So imagine that we took one population and found a mean of whatever we're looking at. Let's say how much money, the average money they had, and then we took another population and we found their average. Well, we're saying for each of those populations we've taken, how far do they stray from the overall population mean, right? So that is what we'll talk about by standard error. Now, why is this very important? This is not just a technical issue that I'm just trying to bore your minds with. It is very important for us to understand this, to know the do's and don'ts of reporting of estimates. The whole premise of calculating standard error is based on the assumption of random selection. So, in other words, the only mathematical basis for calculating standard sampling errors and standard errors is that the samples were selected at random. So, we now end up with problems like this where, let me show you. This is the point we're trying to make ultimately. Here, you see the authors. I removed their names because the focus is less on who they are and more on the issue we're trying to address. They indicated that respondents were recruited using a combination of snowball sampling and street outreach. So bottom line, this is a convenient sample. Now, when it comes to how they report estimates, you see they report the percentages with standard errors. Now, this is a no-no. You cannot report standard errors when you are using a convenient sample. Why? Well, let's go back to our slide. That is because the only mathematical basis for doing all of this is that this sample and this sample were drawn at random. So this is why you need to understand what you can, not everything that the output gives you is useful. So when you run, of course, when you run analysis on Stata or SAS or whichever software you're using, the software will give you output. It will give you the confidence intervals to give you standard error. But you are expected to know as a researcher when you should throw away certain things from the output and when you should use them. Not all things that the computer gives you are things you should use. The computer doesn't know the context. You are the one who knows the context. So see, again and again, I'm talking about context because context matters. So it is your job as a researcher to be an informed researcher and know at least the basics, the foundational aspects of research, right? And so this is important because it has significant implications on how we interpret results from our outputs. I hope that's clear. So now, we mentioned this slide, we discussed the slide, but I'm going to repeat it again because it has to do with the implications for confidence intervals. We need to understand confidence intervals. So for those of you who were, I think that was 2 weeks ago, well, we're going to say the same thing. But for us to understand confidence intervals, we need to understand the distinction between samples and the population parameter. Remember, we said here that how much distance is between the mean of each sample from the population mean. So we're talking about two things here, the sample and the population. What's the difference? Now, we need to understand that concept 100% very thoroughly if we're going to understand confidence intervals, because that's the whole idea behind which confidence intervals are based upon. So here's our analogy. Let's say you want to meet the president of your country. Of course, nobody just walks in and sees the president. So you have to go through the secretary, right? And you just have to hope and pray that whatever the secretary is telling you represents what the president would have told you had you met the president. So in this case here, the president represents our population, right? And this is this guy here, right? This is what the president represents. The chief of staff or secretary represents the sample, which is this guy here. Now, what the president would have said represents what we call the parameter. So remember, the parameter comes from the population, just like the president here is saying 28%. These are the words of the president, right? The president is the population, and the words from the president represents the parameter. The words from the secretary represents what we call the estimate. And that's what we call it, estimate. You should ask yourself, estimate of what? When we say it's an estimate, the only logical question you should ask is, estimate of what? Well, we call it an estimate because it's an estimate of the population parameter, which we do not know. Right? That's why it's called an estimate. So the chief of staff is the sample, and what he says is the estimate. So we only hope and pray that the estimate is a true measure of the population parameter. Now, how do we know though? Because we're never going to meet the president to ask him, well, is it true that you said the sample is less than half or the result is less than half? Well, this is where the confidence intervals come in. The confidence intervals allow us to gauge to what extent what is Mr. Secretary is saying truly reflects what the president would have said. So 95% confidence intervals means that whatever the secretary tells us, 95% of the time, or 95 out of 100 times, it will reflect what the president would have told us had we had a conversation with the president, right? So the 95% confidence interval allows us to assess how much faith should we put in this estimate we have gotten. Is it a lot of faith? Is it no faith at all? And so that's essentially what it is. So it's telling us that if we were to go to this estimate, 100% of the time, 95% of those times, it will match with what the parameter would have told us. So of course, that's the simplified, explanation of it. So technically what we're saying is that if we were to spend our lives, let's go back to this. If we were to spend our lives taking samples indefinitely, right, 95% of the time, the population parameter would fall within the result we've gotten. So if the prevalence here was 10.1, this is the estimate, we're saying that 95% of the time, the true population parameter will fall within this boundary, will fall between 6.5 and 15.2. So remember, 10.1 is what the secretary told us. This is the estimate. But we're saying, okay, how much confidence should we put in this estimate? The confidence interval therefore tells us that if we were to take an infinitely large number of samples, in 95% of the cases, the true population parameter will fall between 6.5 and 15.2. So the tighter the confidence intervals, obviously, the more confidence we have. It tells us that, wow, this estimate is really, really close to the population parameter. Obviously, the wider it is, that means that we're not very confident in it. Imagine that this confidence interval range from 1 to 100. Well, that means that we can't put a lot of faith in that estimate, So you have to understand how to interpret confidence intervals. You also have to understand how to use them practically, the limits of their use, right? What can we use confidence intervals for, and what can we not use them for? So that's very important. It's also very important to know that when we say wide confidence intervals, that's the same thing as saying that the estimate is imprecise. So if you hear terms like, oh, the estimate is imprecise, that's another way of saying that it has very wide confidence intervals. Another point to note is that validity and precision are not the same thing. Validity has to do with is what the secretary told us what the president actually said. Imagine the president said 28% and the secretary told us 10.1. Well, 10.1 is not the same thing as 28%. So in that case, we can conclude that estimate is not valid. So validity applies to the point estimate. Precision applies to the confidence interval. So that's why you have to report both the point estimate and the confidence interval, because we need to know both about the validity and the precision of that estimate. So we can minimize the sampling error or the issues of precision with sample size. So the larger the sample size you have, the more precise your estimate will be. So the narrower the confidence intervals. So you can see here why science researchers sometimes make a mistake where they will tell you that our estimate is very large or our sample size is very large, so our estimates are valid. It's like, that does not even make any sense. You are saying the large sample size affects the precision, but not validity. So you are drawing inferences, you're making a claim about validity from something that has no bearing on validity. So the only thing you can say is our sample size is very large, so our estimates are precise. You cannot say our sample size is very large, so our estimates are valid. No, that's wrong. So we need to know what affects what. Validity is affected by bias, so we can improve it by addressing threats to validity, whereas precision is affected by error, and we can address error by increasing the sample size. So we need to understand that fundamentally. So a few do's and don'ts of reporting percentages and means. Try to report percentages to one decimal place for large samples, or to no decimal place if the sample size is small. You need to follow suppression rules. Not every estimate that your computer gives you should be published. So you need to understand that the computer, of course, will give you output. That's its job. Now it's your job to interpret the output and decide on what ought not to be displayed and what ought to be displayed based on your subject matter expertise, right? It's not something that AI will do for you or some computer will do for you. You are the experts. You are supposed to interpret the results and make it make sense. Percentages should be accompanied with 95% confidence intervals, except when you're using a non-probability sample where you should just report the percentages just like that. Now, when you are using weighted analysis, always interpret the data in terms of the parent population, not the sample. What does that mean? Imagine you took a national sample of, let's say, the US, right? And you weighted the data. The sample was, let's say, 500 people or 1,000 people. But there was probabilistically selected, and you weighted the data to be nationally representative. What we're saying is that when you're interpreting your result, you cannot say 50% of the analyzed population were smokers. No, you can't, right? Because once you weight the data, the inferences are now to the population, not to the sample. We're going to show that in a minute, right? But those two things are very, very important to keep in mind with weighted data. Don't display confidence intervals for non-probability based samples because there's no mathematical basis for estimating sampling errors. Beware of sampling of eyeball tests. We'll talk about that in a minute. I'm going to go through a demo now. Eyeball tests are dangerous. You should know when to use them and when not to use them. When two confidence intervals do not overlap, that you can infer that there's a significant difference between the two estimates. However, when they overlap, that doesn't preclude significance. Just wait on for the next few slides. We'll emphasize more on that. And when you are doing descriptive analysis, don't just perform indiscriminate statistical tests because you can end up with a lot of false positive results, which is what we call type 1 error. This is JAMA's instruction for authors. JAMA is the Journal of American Medical Association. A few things they've highlighted here, which I just thought we should share. Let's see. This is, let's see the most important ones. Do not use decimal places. E.g., report XX percentage, not XX point XX percent, if the sample size is less than 100. Again, in general, you want to restrict percentages to one decimal place. But if sample size is small, well, JAMA told you 100, but there's no rule of thumb per se, then you should express it to 0. There's no decimal place. So that's just some things we wanted to flag. We talked about this already. Now, just to put the issue of weight in the picture, I love pictures because the picture is worth 1,000 words. This is a very, very simplified edition of what happens when we use weighted analysis. This is your data that is not weighted. This is your population that you're trying to make inferences to. When you weight your data, what happens is that you're taking this lump of clay that is very amorphous, and you are forcing this clay to resemble the population. So this is our population. This is our data before weighting. This is our data after weighting. Now, it's very important to note that what weighting does is that it creates a pseudo population, a fake population. That population does not exist. It only exists for statistical inference. So what we're saying is that when you're now making your inferences, don't compare this guy to this guy anymore. This guy is dead and buried once you weight the data. Instead, compare this guy to this guy. Why? Because that's the whole point of weighting. So once I weight my data, I cannot say 50% of the participants were smokers. No. It shows that I do not understand the foundational aspects of what I'm even trying to do at all, or how it's supposed to be interpreted. So I can't say 50% of people in the sample were smokers. No, I have to say 50% of this population were smokers. That's how you interpret it correctly. So that's something we want to keep in mind when we use weighted analysis. Now, we also have to make sure that we, please, can we stop making the scribbles on the screen, please? Thank you. So there are suppression rules. I always thought that word is a very funny word, like suppression rules. It feels like you're suppressing individuals. But to be clear, we're suppressing estimates that are not valid, that are not precise, rather. So suppression rules are rules in place that helps us know when to report certain estimates and when not to report them. The bottom line is that we don't report estimates that are very imprecise, right? But you don't just wake up and decide that, oh, I'm not going to report certain estimates. There are rules that we follow in general. And in general, we look up to NCHS, the National Center for Health Statistics, to give us those guidance on how to follow. And generally, of course, it's not a rule of thumb that you must follow, but the scientific community in general tries to follow the rules or the standards set by NCHS. So to be clear, they are standards. They are not rules. So we don't want to be stickler for rules. Somebody will say, oh, but this is how you must do it. Well, they're standards. And so we must understand them in that context. But let's proceed. So the idea is that it starts with you calculating sample size. We always want to avoid issues of medicine after death, right? So while we are focusing on interpretation of data, when you're designing your study, you have to give a lot of thought to those things. And we'll talk about that, a little bit further downstream. But this is very important. Calculate sample size at the very beginning so that we don't have to worry about medicine after death. Then, is the nominal or effective sample size less than 30? If it is less than 30, then suppress. So if you're using data that is just 20 people in a cell, well, why are you telling us information based on 20 people? The result is very imprecise, right? So by NCHS suppression rules, we will just suppress those estimates from cells that are less than 30. So let's say you have gender, male, female, and other. You have 300 males, 400 females, and 15 other. Well, you can't report the estimates from those 15 people because they are too few, right? So you just put a dash. That's what we're saying. Then the next thing is, so let's say there are more than 30 people. The next thing to consider is, okay, calculate the confidence interval. The next thing to consider is the absolute width of the confidence interval greater than 0.3 or greater than 30%, right? The absolute width is simply the upper confidence interval minus the lower confidence interval. So in this case, the absolute width of this confidence interval is 15.2 minus 6.5. NCHS is saying that distance, that gap should not be more than 30%. If it's more than 30%, that means that the estimate is imprecise. So let's go back to our algorithm. So if it's more than 30%, what's the decision? Well, suppress. So it's possible that the sample size may be more than 30, but you might have very wide confidence intervals. Don't give us very wide confidence interval and then tell us, oh, you should interpret it with caution. What does that even mean? Interpret with caution. Like, why give us something bad and then give us the job of interpreting with caution? Why didn't you suppress it yourself? So that's the whole point, right? So this is the flow here. And then if it's less than 30, then is the absolute value of the confidence interval width less than this, and so on and so forth. But I just want to focus on this part here as being the most common elements we use for evaluation. So let's look at a practical example. This is a report, from many years ago at CDC. Well, we're looking at the prevalence of smoking in the nation across, in the US. So this is going to be our pop quiz now. I've been speaking, so now it's your time to speak. So I'm going to ask you questions based on the outputs, and you're going to apply what we've learned in the past few minutes to answer them accordingly. All right, so this is table 1 showing the percentage of persons aged 18 years who were everyday or someday tobacco users among those who met thresholds by tobacco product and selected characteristics, National Adult Tobacco Survey, United States, 2012, 2013. Who can tell me the key elements that are present in the title? Because presentation of results starts with knowing how to present the title properly. So epidemiology is all about description of person, place, and time. Those 3 words should be stuck to your brain. Person, place, and time. That's what we do in epidemiology. Your title must contain those elements of person, place, and time. If you don't present us with person, place, and time, how then are we supposed to interpret the results? Remember, you're not writing for yourself. You're writing for other people. And remember we said that data is not just information, right? We have to take context and add to the data for us to get information. So if I don't even know who the person, place, and time is, how am I supposed to get context to even interpret the results from your work? So you should try to make your tables to be what we call standalone. Standalone means that we don't need you to be there to interpret the results for us. We can read it and say, oh, okay, we see that this estimates were among this population. Now, I have removed the footnotes because, well, this is the pop quiz. Now, who can tell us why these things are, why do we have a dash here? I've removed the footnotes, but I want somebody to hazard a guess as to why we have dashes in the midst of tables there. This is your time to speak.
Amina, you can unmute yourself.
Thank you very much, Prof. I'm thinking either because the confidence interval is too wide, or the sample, the sample size, I think, like you mentioned, is less than 30. You said if we have this, we suppress.
Which do you think, if you take the table overall, which of those is more likely when you consider every other thing in the table?
The percentage, that is the size, is
So,
less than 0.3, or you said 30%.
So when we take this in consideration of every other table, let's focus on 18 to 24-year-olds, right? Oh no, let's focus on this women. Women have data for every other outcome except this one. If the sample size were small, less than 30, what would we expect for women across board?
Okay, Amina is gone. So let's try Andrew. Can you unmute yourself?
Yes, I was going to say something just like what she said, that the confidence interval is too wide. But from what Prof is showing now, it seems if you take the regular pipe, there was a problem with the estimate, so the person didn't want to put it there. Thank you.
All right, thank you. So, but the nuance point I'm trying to push us to is this an issue? Of course, you don't know the context, but as research experts now, right, you should be able to pinpoint what the problem was. Was it an issue of a sample size being less than 30? Or was it an issue of the confidence intervals being too wide? Or was it both? Like, who can clarify that for us so that we're all on the same page?
Okay,
And
Andrew, do you still
justify your
want to
argument.
try? Okay, he's gone. Isaac?
Okay, thank you very much. I think from the data, since I will just go straight by saying that the confidence interval is too wide. Just that. I think the sample size is okay. It's just the confidence interval. And I believe probably the lower interval may be a negative number as well. Just a guess. Thank you. Over.
Can you justify why I say you on the line? Can you justify why you say it's likely an issue of confidence intervals, not necessarily an issue of sample size?
Yes. So when you look at the other parameters among the women, I think the sample size was within the 30% rule. And that, as a matter of fact, they were able to produce some percentages. But when you come to the regular type parameter or variable, it looks as if the interval for that one was extremely wide to generate a percentage for them to actually fit in with that proportion.
Excellent. So we know that by exclusion. But while I still have you on the line, you mentioned that when we look at the other parameters, are these things we're looking at here, are these numbers parameters? Or what
Sorry,
are they?
so they are estimates. They are estimates.
Okay, good. Please don't get us in statistical trouble, okay?
Thank you very much.
We never know what the parameter is. They're estimates, right?
Yes, please. Yeah, they are estimates. Yeah.
If it were a parameter, would we need the confidence interval if we had a parameter?
In fact, that was my question for you. I raised my hand for a long time, but I wasn't given the chance to
Oh,
talk.
great. Now answer the question now.
So for what I understand now, once the president has spoken, that is final, that is it as it is. So we wouldn't need a confidence interval. That is what I got from the explanation.
Excellent.
But once the chief of staff is speaking, we will need confidence interval.
Excellent.
Thank
so
you.
Your understanding is very clear. So now, is there a significant difference between men and women in the prevalence of any tobacco use? What do you say? But first of all, right, let's before we get to men and women, let's look at age. Is there a significant difference? And the whole point is, what we're trying to do now is, you should, at minimum, be able to interpret output without getting any additional information. Why? Because you're experts. You should just take an output and say, oh, wow, this is what's happening here, right? That's the whole point of you developing expertise. Now, we need somebody who will now tell us, is there a statistically significant difference between the prevalence of, we observe among the older adults, 65 years or older, versus 18 to 24 years old for this product, any tobacco product use? What do you say? And you have to justify the reason, obviously.
Okay. Momo, are you still here? Okay, Emmanuel?
Okay, good evening. So, from what I've seen, I think there is a significant difference between older population greater than 65 years, greater than or equal to 65 years old. There's a significant difference of tobacco use between this age group, greater than 65, greater than or equal to 65, and the rest of the population. Because if we check the estimate, we have 9.5% who were reported to have used any tobacco product. And looking at the difference between 9.5 and those in the age group between 45 to 64, and then those in the age group between 25 to 44, and then 18 to 24. There seems to be a significant difference between the prevalence of tobacco use among these age groups.
Okay, thank you. Your answer is correct, but your explanation is wrong. Who wants to build on that and give us a more defensible answer? He focused on the estimate, but what should we be looking at?
Ibekele.
Yeah, thank you, Prophet. There's a significant difference for the age group 18 to 24 and those that are greater than 65 for any tobacco use, because when you look at the confidence interval for both, there is no overlapping. The one for 65, more than 65 years old is far away from that of the 80 to 24. The upper limit of the one for 65 years and above is 10.1, whereas the lower limit for the one for 18 to 24 years old is 22.3. So there's serious disparity between the two groups. So there's no overlap.
Excellent. Very, very good. So that is why we know that so I don't need to run a statistical test. This is what we call eyeball test. I just look at it and go, okay, oh, there's a significant difference, right? You need to be able to interpret results on the fly rapidly, because when you're in the field making decisions, you don't have the time to go and start doing all manner of statistical tests. So the ability to interpret results on the fly is very important. Now, is there a difference in the prevalence of any tobacco product between those aged 25 to 44 versus 45 to 64 years old?
Okay, Isaac?
Yeah. Hello.
Hello.
Okay, so yeah, Prof. Thank you. So between the two age groups, once it does not overlap as well. So therefore, there is a difference, statistical difference between the two.
Okay. All All right, thank you. Now let's look at this group now. Let's look at this. Oops, sorry. Among whites and blacks, is there a difference? Is there a significant difference in smoking of any tobacco products between whites, non-Hispanics, and blacks, non-Hispanics?
Isaac, you can continue.
Yes, it does, because it overlaps. When there's an overlapping CI between the two age groups, you look at the blacks, the lower CI is 20.7. And when you look at the white, the lower CI is 20.1. And that is within that range. So for me, I would say yes, it does overlap. And for that matter, there is a statistical difference.
Okay. So your argument is strong, but the conclusion is completely wrong.
Oh, sorry. There is no, once it overlaps, there is no statistical difference. Sorry.
Okay. But the answer is wrong. Who wants to take another try? And thanks so much for your efforts. That the answer, your reason is logic is clear. But this is a trick question. So don't feel bad. Who wants to take another stab at it? Is there a statistically significant difference between whites and blacks? Like
Someone
I said,
in the chat says no significant.
That's
no
wrong.
Significant difference.
That's okay. That's a wrong answer.
Okay, Charles says there is a significant difference in smoking prevalence, with Black individuals having a notably higher smoking rate.
That is the wrong answer.
All right, let's try Faraja. Please unmute yourself. Faraja.
Hello, can you hear me, please?
Yeah, we can hear you.
Yes, trying to see the ranges for these two groups of people, I can say that there is a tight relationship between these two ethnic groups, because once we see the CI for white group of people 20.1, and we see our estimates 20.7, and we can see as well the black people, the CI, lower CI is 20.7 up to 24.3, and we see the estimate is 22.5. So on my point of view, I can conclude that we do have many any tobacco product, we do have a little bit difference between the white ethnic group and the black ethnic group. It's a little bit difference. There is a little bit difference between these two groups once we see where our estimates fit within the interval, the CI intervals between these two ethnic groups. So we have a little bit difference between these two ethnic groups. This is my analysis. I don't know whether I do get it or not.
Thank you very much, but you're wrong. We'll take one more trial. Like I said, this is a trick question. I literally told you guys this is a trick question.
Okay. Dr. Eric, please unmute yourself.
All right. So let me try. So since we have the estimate of the black, or the whites within the confidence interval of the blacks, in my opinion, there is no statistical significance, because the estimate is within the confidence intervals of the blacks.
Okay, thanks. So half of the people have said it's significant, the other half have said it's not significant, and I've constantly said the answer is wrong. So what other answer could possibly exist? So those who said yes, I said no, that's wrong. Those who said no, I said that's wrong. So what answer do you think I'm looking for?
Samson?
Yeah, I think there is a need for maybe a further analysis or control for some confounders or do some stratification, something, because the blacks have got the sample is not precise for the black. The estimates, the precision is very wide, whilst the range is wide. Whilst for the white, it's more precise. So we may need to do some extra analysis, whether to check for some bias, confounding, something. Yeah.
All right, thank you. So the answer I was looking for is we don't know. That was all I was looking for. Is there a significant difference between whites and blacks? We don't know. The only way we can do is to do chi-square test or any other statistical test. We can't know just by looking at it. That's why I said it's a trick question. And the whole point of dragging it out is to make sure that we're really instilling you not to do that, not to make inferences comparing two estimates when there is an overlap, because you don't know. The presence of an overlap, that's what we said earlier, right? We said the presence of an overlap, beware of eyeball tests when comparing two estimates. Non-overlap always means they are significantly different from each other, but the presence of overlap does not preclude significance, meaning that they could overlap and still be significantly different. The only way you can tell is to do a proper statistical test. So beware of that. That's a very, very common flaw you see in papers submitted to journal, to a journal where I serve as editor-in-chief, where people just look at do an eyeball test and like, oh, we assessed, and that should be a red flag for you as a reviewer, or if you're a supervisor where your student says, we assessed statistical significance by comparing the overlap of confidence intervals. It sounds fancy, but it's so wrong. Like, why are you doing that? That makes no sense. You only have half of the story. You can only tell those estimates that are not overlapping. The other half, you are very likely to get it wrong. So bottom line, the reason why we've gone through this rabbit hole is to really, really impress that on you, that when the confidence intervals overlap, the only answer is we don't know. You have to test for that to know. All right. Now, like we said earlier in the flow chart by NCHS, you really don't want medicine after death. So don't wait to collect your data and then start wondering, geez, how are we going to manage this, right? So there are some considerations you want to keep in mind, because the quality of inferences we make is only as good as the quality of data we collect. And so we need to pay attention to missingness patterns. Not all missingness are the same. You can evaluate missingness with the SIMPLE framework. SIMPLE just is an acronym that means skipped, ineligible, non-response, partial complete, and other patterns not otherwise specified. This is why it is so dangerous for you to just use AI software to just analyze your data. The person who wrote that software may have no single idea of how data is supposed to work. And you're somehow putting all your faith and credibility in what they've written as software, right? And they say, oh, just put in your data set and we will replace all the missing values with averages. Like, really? That is horrible. You should never do that, because obviously missing because you were ineligible or because you had a skip pattern is not the same thing as missing because you had a partial complete or you are non-response. Those are completely different things. So this is why we say context matters, right? You can't just do a blind treatment of everything. Context matters. So that's a key word for today, context, because everything boils down to context. Data cleaning should not be medicine after death. Don't wait to collect bad data and then you say you're going to worry about cleaning. So consider those issues right at the beginning when you are collecting data. If you desire to have a generalizable data set, then you must make sure that sampling is probabilistic, right? If your goal is to calculate confidence intervals, at the very beginning, you should plan for that. You should make sure that your sampling reflects your analysis plan. This is why you don't wait to the end before creating an analysis plan. If I'm reading your analysis plan, so if I'm supervising, students, this is a requirement. I don't want to wait till the end before you show me at the very beginning, you must create a PSAP, a protocol, and a statistical analysis plan. I need to see how you're going to analyze the data before you even get the data, right? So if you're telling me that, oh, we're going to calculate prevalence and confidence intervals, but you're telling me that you're going to do a convenience sample, those two things don't add up, right? So like, do you even know what you're talking about? It seems you are completely clueless. And I think you need additional education before we can give you this PhD that you so desperately want. So so you have to know what you're doing. That's the point I'm trying to say. You have to plan right from the beginning before you do your study. And so what I want to do now is to see how we can take these considerations and apply them when we are designing the study at the very beginning. So I'm going to go ahead and take I had a mock questionnaire that I created to, let's see if I can pull it out. Let's see. Right. So I have a mock survey here that I wanted us to see how do we go through the whole process of thinking through the different design issues right from when we're conducting the survey, not waiting at the end, right? So here, this is my survey that I just want to do. The objective is to assess the association between exposure to ChatGPT. This is just a hypothetical case, so you have to treat it as such. I want to know whether there's a link between exposure to ChatGPT and academic performance among college students. So I have a few questions here that I'm trying to measure on different things. It includes things like their usage of ChatGPT and all of that. Now, this is going to be a survey that I just want to use for this research, but I may also have other objectives. It might be a multi-purpose survey. So I have to consider those things. I have to make sure that the sample size consideration is sufficient for those outcomes that I may just want to analyze descriptively, plus this one that I want to do more a comparative analysis, right? I have to make sure of that. I also have to make sure that if I am trying to generate a representative sample, then I sample in a way that is probabilistic. Finally, I have to make sure that the way I set up my data is such that I account for, I reduce the risk of collecting, bad data. You don't want to set up your survey in such a horrible way that you collect all the bad data and then later on you start saying, geez, how do I clean this data, right? So we're going to do a demo of how to set up these things, those considerations, and then quickly see how to also interpret the data and the analysis. So here, let me go to the Chisquares platform, and we're going to do all of those things. For those of you who are new, the Chisquares platform is a tool for various aspects of research. Think of it as a one-stop shop where you can do different aspects of research, from sample size calculation to sampling and conducting of surveys, whether they're cross-sectional or longitudinal. Now, the very first thing I want to make sure is that I have enough people in my study. I don't want to have a scenario where I design a study that down the road I realize that, geez, I don't have enough people in the analysis, and I end up with a lot of cells having missing groups because I have to suppress the estimates, right? So I don't want that to happen clearly. So I need to make sure that my sample size calculation is key. So for that, I'll come to the sample size mode and start a new sample size. So here I can select the kind of study I am doing. Now, for that study, that was like a comparative study where I'm trying to compare the academic performance between students who use ChatGPT for their work versus those who do not. So that will be a comparative study with two arms, because it's people who are using ChatGPT and those who are not using ChatGPT. Now, what if it was a survey that I'm doing that I want to use for other purposes beyond just that comparative analysis? Well, in that case, I will have to do two sample size calculations for the sample overall survey and for this one, and see which one gives me more sample size. And then I'm going to go with the more, because you have to be conservative. Conservative simply means you plan for the worst. So planning for the worst means that, well, I have to protect myself with the largest sample size that is required under those different circumstances. So here, we're going to go with comparative study with 2 arms with the percentage as outcome. The study type here, this seems to be, let's say, maybe this is a cohort study. I'm just trying to follow them for maybe 1 year and see at the end of that 1 year, what do the academic performances look like? So if you're calculating sample size for this kind of context, you have to provide the prevalence of outcome among the non-exposed group. So in this case, the non-exposed group are the individuals who do not use ChatGPT. So the question I'm asking is, what is the percentage of failure? What's the failure rate among the students, or among those who are not using ChatGPT? What percentage of them do I expect them to have poor grades? Now, I may not know that number exactly, so I can use the overall baseline rate. So in the overall population, what is the failure rate? Let's say the failure rate is 25%. Now, the next thing is to provide the prevalence of that outcome among the exposed. In this case, those who are using ChatGPT. What percentage of them do I think will have the outcome? Now, sample size, as you can see from now, there's no such thing as a correct sample size. Sample size is all about making a very, very educated guess, because the sample size you get is based on the assumptions. And once assumptions enter into anything, we're in guess land. So you just want to make sure that your guesses are as plausible as possible, and that you do a lot of sensitivity tests to see, all right, what range am I getting? And you might want to be more conservative by just going with the larger one. So here, let's say that we estimate that the prevalence of the outcome among the exposed group will be 15%. We actually believe that ChatGPT will improve academic performance. So we believe that 15% of those who are on ChatGPT would fail, which is a reduction from 25%. The level of confidence desired is 95%. You should always go for a 2-sided test. It's very dangerous going with a 1-sided test. The 1-sided test, you're saying that, you know what? I am so sure of myself that I don't even need to do this research. It's like, but if you're so sure of yourself, why are you still doing research? The whole point of research is to know what we don't know. So a 2-sided test says that, well, I think that ChatGPT might help students improve, but I'm also open to the possibility that it will actually worsen the academic performance. So it can go either way. A 1-sided test, what you're saying is that, well, I think that ChatGPT will help students, and I have blocked my mind to any other possibility that it could go the other way around. The implication of a 1-sided test is that you get a very relatively smaller sample size, but you only answer half of the question. So if I say that ChatGPT will help students, and my study eventually found that it doesn't help students, my conclusion would be that this study found no difference between ChatGPT and non-ChatGPT use in terms of helping students. But that only answers half of the question. The other half of the question is, well, did he harm them? I can't answer that part of the question. Why? Well, because in my great wisdom, I chose to do a 1-sided test, and I don't have enough sample size to test the other side of my hypothesis. That is the moral of the story is just always go with the 2-sided sample test if you're unsure. The power represents the ability of your study to detect differences. Obviously, the higher the power, the higher this number, the higher the power. It's a probability that ranges from 0 to 100 or 0 to 1 as a proportion. And then you put in the expected response rate. So maybe I expect that 40% of the people will respond. And based on that, I get my calculation as I need 841 people in each arm. So I need 841 students who are using ChatGPT, and I need 841 who are not using ChatGPT. Now, when you calculate your sample size, especially if you are a student, a doctoral student or a master's student, please don't just calculate one number and just come and give it to the supervisor and say, oh, this is my calculation. Remember, there's no such thing as a correct sample size. It's all based on assumptions. So what I would expect from a capable student, or if you're even applying for a grant, is that you do multiple calculations under different assumptions. And then you can say, okay, if we want with this assumption, this is the number we will need. So here, for example, you can say, alrighty, if we went with a power of 80%, let's say, because of course it's resources we have to worry about. How many people would we need, right? If we change the anticipated response rate, how many people we need? That just shows the reader that you are diligent and that you've given thought to different scenarios. Because of course, there's one, Mike Tyson said everybody has a plan until they get knocked in the mouth, right? When you're conducting studies in the real world, well, things happen, right? The number you thought you will recruit might not happen. So what happens? So that's the whole point of making sure you have some sensitivity analysis to your sample size to do that. Now, if I were doing this with a survey, I might also want to do the sample size for just the survey and see, okay, here I got 1,256. How many people would I need if I were doing just designing as just a cross-sectional survey? Let's say I'm doing 95% as level of confidence, the prevalence is 50. I want to do cluster sampling, and let's say I put design effect of 2. I want to stratify, or maybe not. The margin of error is 5. What sample size does that give me? It gives me 1,921. More or less, they're about the same. So those are some of the practical things you need to think about, right? It's all about thinking about what could go wrong and how do I prepare myself for any eventuality. Now, like we said earlier, if you want to make some inferences that are generalizable, that should be reflected in how you sample. You want to make sure you draw a representative sample. So in this case, my study might be, let's say, of the US population. Let's say it's a household survey. Well, in that case, you select the country, let's say United States. You select the states you are trying to sample from. If it's a national sample, you can leave it blank. And you select the number of clusters. We've talked about clusters. I believe everybody here who has been in our classes should be an expert in strata and clusters and all of those, because we've talked about it like a million times. So, and you enter the sample size you need, which is like 1,900, for example, and click on Get Samples. The platform applies a probability sampling technique called a two-stage PPS. You can read more about it from the methodology report here, and gives you where you need to sample to make sure that your data are representative. So you have the data as a map, but you also have it as a table for you to visualize. Sorry, my internet is a bit. So this tells me where I have to go to sample for my data to be representative. I can also get the same data in the table here. So that's about the sampling part. Now, for the survey design, you want to really make sure that, like we said earlier, you pay attention to how you set up your survey so that you reduce the risk of bad data, because there's nothing worse than collecting data and then you have to start worrying about cleaning the data. So let's quickly look at some of the things that we could do to make sure that our data is good quality. So our title was, what was it now? Comparison of academic performance between students using ChatGPT versus non-users. So that's our hypothetical title. Location of study participants. That's the United States. The primary aims we can just generate with AI, so that we have something to go with. And then the keywords as well, we can also generate those with AI or manually as we might. So the AI gives you a lot of suggestions. You can pick the ones you want. Obviously, it's your study. So here I can select 2. You can edit the aims you've selected if you wanted. And the same thing with the keywords. You can put in the keywords manually, or you can generate with AI. So I'm gonna just type in a keyword like academic performance. And once you're done, you can now create new projects. So it's a collaborative platform. So that means you can obviously work with many others, like your supervisor. If you're a supervisor, this is a great way to know whether your student is to provide feedback in real time. So you don't wait for them to do all the wrong things before telling them that, oh, well, all the work you've done the past 3 months is nonsense. You have to start all over again. So working on a collaborative platform helps in that regard. So if you want to add a collaborator, you put their email and you send them an email. And do that. You assign them a role and you save. And what that does is that sends them an invitation to onboard as a collaborator on your project. So now I can add questions and make sure that I pay careful attention to issues of threat to validity and making sure that my data collection is done in a way that makes sense. So I'm just going to import the questionnaire from Word. There are different ways to add questionnaire. If you don't want to start typing manually, you can import from a Word document, for example, which I'm going to do that. So I've already created a questionnaire as a Word document, so I'm just going to import it now. So that was it here. So this is my questionnaire. Now, the point we're trying to make about data quality is that you should always make sure that you set up your data in ways that will collect meaningful data, especially when the questions are open-ended. It's less of a problem when your questions are just like MCQs or closed-ended questions. It's a problem when you're collecting data that are open-ended. So for example, here I say on average, how much time do you spend on ChatGPT each day, right? They're supposed to enter unit, but should they be allowed to enter letters? Well, I might have somebody who will be entering letters, and then I have to start worrying about, okay, is that valid? Or somebody says they spend 30,000 or 3 million, like, is that correct, right? You can prevent all of those things by making sure you set up your data correctly, all right? So in this case, I can go over to the settings and edit them to make sure that they work for me. So I can say, you know what, allow only numbers. So if the user types letters, do not even accept it. And do I want to provide a unit of measurement which already exists? I can also set lower limits and upper limits such that if an individual enters anything beyond that, it will not accept it, right? So these are some minimal things that you can do to make sure that the data you're collecting makes sense. So things of that nature. So pay close attention to your, not just issues of sample size calculation, but particularly when you set up your survey so that you won't have, poor quality data collected. For sake of time, I would just stop here. And maybe in the next session, we can look more at the issues of data cleaning, but making sure we have enough time to answer the questions that people might have. So for those of you who have questions, please feel free to ask them now, and we will answer accordingly.
Thank you. Let's see some hands. Do we have some hands up? Okay, Zachariah. And just to inform you all, we will be sharing the attendance link right now. We call it the evaluation survey. For those who are new, please ensure that you complete everything, especially your name and email address. And we really want your honest opinion on how you found the webinar. So we will share that right now. Please complete that survey and make sure that you provide your name and your email address so we can be able to share a certificate, to send you a certificate after the 3rd session. Okay, so another thing is that people always ask, they always complain, I've seen that the sessions are long sometimes. So just note that as soon as Prof is done with the presentation, the session is essentially over, but we have a Q&A session which can last for as long as we have questions. So otherwise, you're free to leave once you've completed the attendance register. So I'll start with questions now. Chipo Winnie, please unmute yourself.
Okay, thank you so much. I just want some bit of clarity. To be honest, I'm not really very conversant with data analysis. I'm actually learning a lot. We were looking at that other table where the confidence interval was presented together with the estimates. And a professor asked a question to say, like in the first part where he actually asked whether, maybe if you can go back to the table, I'm sorry,
Sure.
it would make sense to me so that I can ask what I exactly want to learn. There's a table that he showed earlier on.
Sorry, just a minute. Let me find it here.
Okay. Yes, that one. Yes. Initially, we looked at data where we were comparing the 18 to 24, right? And the above 65. And you asked a question whether this is significant or it's not significant. And on this part, we said it is significant because the estimate is 9.5, and sorry, the lower value is what? The lower value is 9 for above 90, above 65. And then for the 18 to 24, it's 23.3. Right. Am I correct?
Yes. So what we're saying is that overlap simply means that where the one ends and the other one begins. Is there a gap? This one ends at 10.1.
Yes, and then that other one is
at 2.3. So there's a gap.
22.3. There is a gap.
So that means that they don't overlap. So that means if they don't overlap, that means they're different, right?
Yes.
So that means.
And then when we now yes, so then we compared the black and the white earlier on, later on,
correct.
after we were done. And then we actually said that if I'm going to use that same philosophy, should I say the same concept? Like we did when we analyzed the above 65 and the 18 to 24. In this case, there's not much of it. You see, they're kind of like similar. But then you said these are not significant.
No, I did not say that. I said we don't know, which is
Oh,
not
yeah. We said we don't know. They don't know part of it. Is it because they are almost similar? That means we now need to do another statistical test, or we use a chi-square, or we do a t-test.
So remember we said this test, do you remember the name we call this test? Well, we're just looking at it. We call it the eyeball test, right? We're just eyeballing it. So of course, eyeballing has its limitations. So here, when you look at the lower, where this one ends and where the other one begins, you can see there's an overlap. There's an overlap, right?
Yes, there is.
So the overlap. So the rule here is simple. Let's go back to that rule. The rule is when they don't overlap, we can say they're different. But when they overlap, we can't say they're not different because we don't know. We have to test it.
Okay.
Do you understand?
When they overlap, we're saying we will not be sure.
Exactly.
We will not know.
We will
Yes,
not know.
we can't say.
Exactly.
But when they don't overlap, that's where now we can say it is significant or not significant.
Exactly. So that's the point. You've gotten it right.
Thank you so much.
You're welcome.
Okay. Candice?
Hello, good evening.
Hello.
Thank you very much, Prof. I wanted to get clear about during the introduction when you were starting this lecture, this wonderful lecture. you mentioned something that a bit confused me. You were talking about data interpretation, and you said one of the don'ts is that we should not extrapolate, and you explained that we should not use the inferences we draw from maybe a past event to conclude on the future event. So I am confused a bit there because I think it's from data that predictive modelings are done. Like if you analyze historical data or time series data, usually they make a kind of focus with the data. So can you enlighten me more on that aspect?
Okay, awesome. That's a great question. So, the question calls to heart the issue of the use of observed endpoints in research and when we don't have data. So we can put all the scenarios in this world into two categories. Category one, we have data. Category two, we don't have data. When we have data, we use the data and we make inferences from the data. When we don't have data, we model, right? We generate. So you hear a lot about models. This model was predicted this. Model simply exists because we don't have data and we need to have some kind of information, right? But of course, whenever you can, use data whenever you can, right? Because that data is king. So, but when you use data, stay within the limits of the data, right? If you're analyzing data from 2000 and 2020, like I said, don't try to do everything. You are using data, but you're also saying, okay, I'm still going to go ahead and make predictions in 20 years, 50 years from now. Like that is you're extrapolating way beyond the data. So the bottom line is understanding that the world where we have data and we're using data for analysis and inferences versus the world where we don't have data. Models are simply a simplification of reality. Think of them that way, right? We use models because we don't have data. Like my favorite example to talk about this is like, imagine somebody who has never seen an apple before. And you draw them a picture of an apple and say, hey, this is what an apple looks like, right? The question is, why do you have to draw a picture of an apple? Well, because you don't have an apple. If you had an apple, you show them that this is an apple, right? We don't need models when we have data. We only use models because we don't have data, and we somehow have to make, some kind of decision. So the bottom line, what I was trying to say is that when you're using data, stick with the data. Don't try to do everything. Stick with your data, stick within the inferences, stick within your lane. Don't go beyond the data, because then that's no longer evidence, right? Now this is assumption. Because once you leave the data, everything you have left the zone of evidence and you're now in the zone of assumptions. I hope that's clear. Okay, I'll take the next question only.
Okay, let me read one. Someone asked for clarity. Please mute yourself once you've once you've asked your question. Someone was asking you to please clarify the overlapping. I can't find that question anymore, but I saw it. If you can please go back to that, sir.
I think that's what we just did with the first question. The issue of overlap.
Okay. It was after that, but that's fine. They will watch. Okay, there's the recording. There's another question. Can we report mean, standard deviation, and p-values together? Also, can we report means, what's this? P-values together in one result presentation?
So
Yes.
the question is like, you're asking whether you can. So first of all, you cannot use p-values when you're just doing univariate analysis. So that's clear. So you can't just say prevalence of any tobacco use among the overall population was 21.3% with a p-value of 0.03. That makes no sense whatsoever. That is really ridiculous because you're not comparing anything. So p-values are only used when we're comparing things. If you're not comparing two things, then there's no basis for having the p-value, right? Then now, what if you're comparing things? What if we're comparing all these groups? Should we now have a long list of p-values here? No, that is a hard no, because you are now doing indiscriminate statistical testing. Because imagine if we now put a p-value column here and not p-value column, and now one for all of this as the 8 or 9 products, right? And for each column, we're saying we're comparing men and women versus for any tobacco and men and women for this. No. That's a hard no. That is, your work is very susceptible to type 1 error, because now you are on a fishing expedition looking for p-values that are significant. That's just what type 1 error means. You are hunting so badly for p-values, so you can say, oh, men and women, had significant difference on so and so. And that's why, if you are supervisors, it is your job to make sure that when students submit their proposals, they have their hypothesis stated a priori. This is why even descriptive studies need hypotheses. If a student says they're going to do prevalence of smoking, I need to know what your original hypotheses were, because we're going to hold your feet to the fire when you start testing things. But because it can't just be that you now got the data and you're now testing everything under the sun, because you can't. Because it can't work that way. Hypothesis must be stated a priori, subgroup analysis must be stated a priori, and we must do analysis per protocol, meaning that we must adhere to what we said we're going to do. This is why it's very important for us to develop that culture where students develop a PSAP, a protocol, and a statistical analysis plan. The protocol says this is how we're going to do the research. The statistical analysis plan says this is how we're going to analyze the data. Those two things together allow us to hold people accountable and to develop good ethics in conduct of research.
Thanks, Prof. Zachariah? And also someone, Prof, is asking, when will you cover visualization, since it was planned for today, data visualization for adequate storytelling?
Okay, but you can also visualize it in your mind. I'll cover it next week too. That was a bad joke. All right, next question, please.
All right, thank you, Prof. And I like your humor. I actually want to ask about p-value also. I find it difficult to grasp the concept of p-value as a whole, in a holistic way. So I don't know if you can expatiate a little.
That's what we're going to cover next week.
All right, definitely.
Dr. Abdullahi.
Thank you so much, Prof, for this insightful lecture. Hello, Prof. Can you hear me?
Yeah, I can hear you. Yes, can hear you clearly. Yes, thank you.
Okay, thank you, Prof. Sorry, I have 2 questions. The first one is more of a clarification. While you were presenting, I think in the first or second slide, there was something you mentioned about percentage, proportion, and prevalence. I just wanted a clarification. Maybe I mixed them up when you were explaining that a proportion and a percentage are similar. It's just the limits used for the range. So in that slide, you said prevalence and proportion are simply scaled differently. I don't know why you meant to say proportion and percentage, because I realized that the percentage.
Yes, sorry, that's typo. Yeah, percentage and proportion. That shows that you're paying attention.
Yes, Prof.
Prof. Yeah, sorry, please. It's percentage and proportion are scaled differently. Yes.
Okay, thank you so much, Prof. That was the first thing I wanted to seek clarification. The second point was when you were on the Chisquares platform. I wasn't quite clear with how you selected the power and the response rate and what exactly those entities actually mean. It's a little bit blurred to me. I don't know if you can just shed some light on it.
Sure. So, let's go back to what I did. This is my history. Sorry, that was the other one. So let's say we were comparative study. So all sample sizes are wrong, right? Some are useful. That's the premise which must go. Now the question is, how do I select the power? Well, selection of the power is driven by many, many considerations. Number one, how much money do you have, right? The power, obviously, if I have a power of 60%, let's change the power, for example. And this gives me sample size of, okay, 1046. If I increase it to 90, obviously the sample size is going to dramatically, oh, we're using the different arms now. No, sorry, this was 2 arms rather. Right. The bottom line of what I'm trying to say is that the power desired is a number that you have to live with, because it's driven by not just science, but also resources. Obviously, if you have a bigger power, you're going to need more people. Imagine your study you are paying everybody $10 as incentive. Well, if you have 300 people, that's $3,000. Now the question is, do you have $3,000 to give these people? Let's say you only have just a limited resource. It's all of those things factor into the power. So generally, we want to recommend the power of 80 at least, because we need to consider also the ethical dimensions. The ethical dimensions come into play because why did you just expose? So let's say you have a power of 60, you said you want a power of 60% for this specified differences. So you end up going with 784 people, right? But the probability, remember, power is a probability. Here, what this number means is, what is the probability that we will detect a significant difference should one exist in nature? That's what the power means, right? It's a probability. So we're saying 6 out of 10 times, we're going to detect a difference where a difference exists. Well, that means on the flip side that 4 out of 10 times, we will not detect a difference, even though that difference exists. That's what we call a type 2 error, right? Type 2 statistical error. Now, and any ethical board or any ethical committee, this is their job to tell you, so you mean that you're going to expose 784 people to the harms of your study when you know that 4 out of 10 times the study will not even do the job it was supposed to do. So you just expose them to harm for nothing, right? Because you still cannot answer the question that you set out to answer. That is unethical, and we shall not approve the study. That is what an ethical board will do, right? And so those are considerations that you have to consider about the ethics. So at some point, we need to balance the ethics with the real world issues. So I can say, okay, I don't have a lot of money. I cannot afford to do a power of 90%, right? So I'm going to go with 80. 80 sounds just about right. So it means that 8 times out of 10, if there was a significant difference, my study will actually detect it. Well, that's reasonable. 80% sounds high enough. So the moral of the story is that these are decisions that you have to make as a researcher. There's nobody telling you that this is what you must do. There are decisions that have to be driven by consideration of context, consideration of resources you have, and just how sensitive the study is. If it's a very sensitive issue, obviously I want to make sure that I have enough power, right? If it's something I can live with, something that's not that serious, like, okay, let's just, let's just see. And then if it's also a pilot study, the goal of a pilot study is not to demonstrate evidence. The goal of a pilot study is to demonstrate feasibility. So in that case, I can choose to say, okay, well, in fact, for pilot studies, I don't even need sample size calculation at all. I can just say, okay, I'm just going to get whoever I get, right? Because the goal is never to make a claim that group A is significantly better than group B, but just to say that, well, based on what we've seen on the ground, we think this study is possible because the village chiefs are receptive to us and the youth leaders are also very receptive. We got a number of the people who we spoke to were receptive. The questionnaire completion was good. And so we think that this study is a go. That's the whole point. That's the only thing you're trying to do with the feasibility study, right? So you don't even need sample size, but it's a whole lot of things you have to consider. The same thing applies to the response rate, right? You have to look at what's the mode of survey delivery. In general, response rates are highest for in-person surveys and worst for online surveys and mail surveys. So if you're mailing things to people, they were never going to mail it back, or if you send an email to people, it's going to their spam. People don't read emails, and all manner of things. So in general, you find that response rates for web surveys tend to hover around 10 to 15%. So that's a good response rate, good in quote. Whereas for in-person surveys, they tend to be around, like 55% to 70%, if you're very, very fortunate or you put enough incentive structures in place. So the moral of the story is that there's no one answer. It's all context dependent.
Thank you so much, Prof. Thank you so much. It was very lucid, the explanation you gave. I have just one last question regarding this particular design you use for demonstration. The prevalence of outcome among control groups, you place at 25. Is this an arbitrary value, or is it based on maybe previous studies, for example? And you mentioned that if it was the control design that you wanted to, that you need 2 prevalences. That's what I didn't get clearly. You said if it was the comparative study, I will need 2 prevalences, otherwise to be just 1. So I didn't get that part clearly.
Okay, so an analytic study or a comparative study, right? We want to detect a difference between 2 groups, right? So we're saying this group, this is the prevalence. Now, this is what we expect to see in another group. You have to declare it's a hypothesis, right? This is why a hypothesis must come before every study. My hypothesis is that this is the gap I'm going to see. This is what we call the effect size. The effect size is the gap I think I'm going to see. So the whole research is based or hinged on that gap, right? So you have to provide an effect size. So the effect size is simply the gap between group 1 and group 2. So if you only have one number, well, you don't know a gap yet, right? You need to have 2 things together before you can say, oh, this is the gap between this and this. And so the platform gives you different ways of expressing that gap. You can express the gap as a prevalence, or you can say, oh, I actually want to detect an odds ratio of at least 1.5 between the 2 groups. That's another way of detecting it, of framing it. Or I want to detect at least the prevalence difference of whatever. So if you're not sure of what the prevalence is, you can use odds ratio, because most people think clearly, or it's more intuitive to them to say, okay, I want an odds ratio of 1.5 or 2.0. So you can go ahead and put that in, and still that would also give you the number. So it doesn't have to be prevalent. That's why you have 4 options here. Does that make sense?
Yes, sir. Thank you so much, Prof.
You're welcome.
Okay. Thank you to everyone who's helping us share links on the chat box. Thank you. We appreciate your help. Okay, questions. And if you posted a question earlier, please post it again, because there's a lot happening there. So I will definitely miss your question if you posted it much earlier. Aminu?
Good afternoon,
Aminu?
my state.
Okay.
Yeah, good afternoon in my area.
Yes, we can hear you clearly.
I'm Aminu Hussaini from Sokoto State, Nigeria. I have a question for Proma.
Yes, please go ahead. We can hear you clearly. Yeah.
Yes, sir. Can this sampling procedure be used for both qualitative and quantitative researches design?
So qualitative design is never intended to be generalizable. So meaning that it's not designed to be generalizable, right? And so it will not be necessary for you to go through all of that, process for a design that was never meant to be generalizable. However, sometimes you might be doing a mixed method study where you have a quantitative component and you're sandwiching a qualitative component in that part. So you expect to get some results which you intend or hope to generalize. So in that kind of context, you can obviously use it. But again, it's context dependent. It depends on what you are trying to achieve.
Thank you very much, Prof. Thank you very much. I really appreciate it.
Okay. Veronica?
Good evening, Prof, and good evening,
everyone.
Prof, I have 2 questions. The first one is, if I use a chi-square platform to calculate my sample size, how do I reference it, please? Then,
okay, go ahead.
And secondly, if I'm carrying out my study in more than one location, I'm in Nigeria, for instance, Cross River State and Akwa Ibom State. If I determine my sample size, do I multiply it by the number of locations or by the number of states? Or how do I go about it, Prof?
All right,
Thank you
thanks.
so much.
You're welcome. So for the sample size calculation, when you calculate, you just click on show reference.
Okay.
And it will display the formula, but you can also see the citation, which you can just copy. So that's the first part of the question. The second part of the question is, what is my population? So sample size calculation is agnostic of the population size. What that means is that if I'm doing, let's say, a survey, and I'm trying to calculate sample size, it doesn't matter whether that population is 1 million. So if I calculate sample size for this, get results, this is 1921, right? I can add more zeros, 1921, right? I can keep adding 1921. The point is the sample size for surveys, it does not matter. It does not depend on the population size. So it doesn't matter. So the sample size you're going to need, and now this concept is very hard for people to wrap their head around. The sample size you need for calculating the sample size in, let's say, Abuja, Nigeria, will be the same as that for the whole Nigeria, because population size does not influence sample size. The only time that it does influence sample size is when the population size is rather small. So if we drop the population down to something really small, see, now we don't have 1921 anymore. It's now 1727, right? And that is related to the concept of finite populations and the need to implement a finite population correction. When we do sampling, there's the inherent assumption that our sample is infinitesimally smaller than the population. That the sample is very, very, very small and the population is very, very, very big. So in that case, the sample is like tasting soup when you're cooking. The amount of soup you need to use to taste does not really depend on the size of the pot. So it doesn't matter whether the pot is very, very big or the pot is just medium big. It's the same amount of soup you will need to scoop to taste the whole pot, right? So that's the whole idea. But when the sample size when the population becomes relatively small, the sample size here changes because we need to correct for that fact that the population is finite relative to the sample. So the short story to your question is, no, you don't have to multiply the sample size by 2 just because you are, because both states are part of your population. So you don't have to multiply it. You're treating them as one population in which you want to design your study.
Thanks, Prof. Let me read one question. Prof, thanks for this explanation again and again. Is it that I don't need p-value in interpretation via eyeballing?
So your eyeballing will only tell you half of the story. Please don't use eyeballing. Okay, let me add this caveat. Please don't use eyeballing in formal context. Eyeballing is just a way for you as a good researcher, you need to know how to use eyeballing, but you also need to know how to do the proper thing. Eyeballing is helpful when you are in quick circumstances that you need to interpret data and you have to make decisions. It's not every time you need to make a decision and you have to go and start analyzing data. You should be able to pick a report and say, and tell a story from that data without a lot of other parameters in that context, right? So a basic skill set of any good researcher is the ability to do eyeballing. But when you're doing a formal research, don't do eyeballing. You should do statistical testing because it will only tell you half of the story.
Thanks, Prof. Let me read a question from YouTube. There's a submission that the pilot study sample should be at least 10% of the study sample. What's your take on this?
So submission by who or from who? There are a lot of submissions out there that are completely arbitrary. No, there's no such requirement, because the very purpose of a pilot study is for feasibility, not for inferences, not for generalizability, and this is the the commonest errors or mistakes people use for use with pilot studies. One is they use pilot studies and then they talk about preliminary effect size, right? One of the things that you should definitely avoid doing is taking results from a preliminary study, a pilot study, and plugging it into your sample size calculation. That is a hard no, right? So let's say you did a pilot study and you got an odds ratio of 1.5 or 2.0 between the two groups you're comparing. And you're like, oh, well, I've done a preliminary study that showed this effect, so I'm going to use that effect. Well, now we're really in a pickle now, aren't we? Because you are using a round peg in the square hole, or how about to say it, right? The study, anything you're going to get from a pilot study is lies and bias. It was not designed to tell the truth. It was designed to tell you answer issues of logistics. A pilot study is primarily designed to answer questions about logistics and feasibility, not questions about science, right? So when you now take that estimate from a pilot study to plug into your sample size calculation, that is just creating a snowball of just disaster, because it is wrong. You can just the safest assumption is that anything you get from a pilot study is wrong as far as the science is concerned, because it was never set up to answer questions of science. It was set up to answer questions of logistics. So that's the most common thing you see, how people misuse pilot studies. They will get estimates, they call them preliminary efficacy estimates. That does not exist. Number two is people actually just use them to generalize. They'll say, well, we did a preliminary study which shows that X, Y, and Z, so we can cautiously say that this result, no. You cannot cautiously or unconsciously say anything. That is not why it was designed. And then the third and most dangerous reason or area where people use pilot studies is in areas of safety. I worked in the pharmaceutical industry for a while as director of epidemiology, and that is one of the most horrifying things that you'd see, where people base results of safety on the backs of small pilot studies. That is a hard no, right? It's a hard no because for you to detect a safety signal, you need a lot of people, right? And you need to follow them for many, many years. When you come up with a safety study and you say, oh, this study is safe based on how many people, 50 people, that is a very dangerous thing to do, because you are giving us a fake sense of reassurance for something that is not true. So please don't use a pilot study for any of these things we've mentioned, because that is not what it was designed to do.
Thanks, Prof. I'm going to read another one from YouTube. If I use a multi-stage sampling in which the first stage is purposeful and the second stage is random sampling, can I still report standard errors?
No. It's a one drop rule. It's all or none. It's either it's all probabilistic or it's not. So you can't say, oh, I'm going to use that first stage as that can work. What you should do instead is that you can define your population however you want. The definition of your population is not something that is random. Obviously, there's a reason why you choose to do your study in Nigeria or to do your study in Lagos and Ibadan, for example, right? The choice of a population is a subjective decision, and you can do it however you want. So instead of selecting the first stage as a stage of sampling, you should define that first stage as a stage where you define your population, and then within that population, you can then select probabilistically. Then your study can have external validity. So it's a fine trick between knowing when to sample and when to define a study population, because it makes the whole world of difference.
Thank you. Odunsan, can you unmute yourself?
Thank you very much, sir. I would like to ask, when you were explaining some things earlier, you said percentages go with confidence interval. So I would like to ask, how were you able to or how did you generate the the estimate for the CI, for the confidence interval in that table?
Oh, we use software. We don't do it. We don't sit down and do it by hand. We use software for that. We'll do some of those maybe in the future session. That is hands-on. This session is not supposed to be hands-on. This particular series we're doing is definitely not hands-on in terms of actually doing it. It's more of how do you interpret it. So if you really want to learn about that, just make sure you follow our sessions. We're going to have a session on estimation of actual estimation. Then you can learn.
Okay, thank you.
You're welcome. And thanks. I've corrected the prevalence to percentage. Thanks for whoever caught that.
Thank you. Please explain what you mean by getting a statistical plan before embarking on research.
A statistical analysis plan is like a protocol. It's like a document where you're going to say, my aim one, here's the aim one, here are the table shells. So we don't expect you to have tables, but you must have table shells. Table shells show this is how table one, these are the variables, this is what they're going to look like. You can also create dummy data and present it. So it's like you're actually reading a paper of the analysis, just that you don't have the data, that you are telling us in advance everything that you're going to do. The reason why you're telling us is that so that we can hold your feet to the fire. So that when you come back with the 1 million statistical tests and 1 million p-values, what I'm going to do is I'm going to go to your statistical analysis plan and say, you never said you're going to do that. Why are you doing it now? Is it that, no, that is, we cannot allow, you can't just be moving the goalpost in hunt of a p-value. So it's good practice for you to create a statistical analysis plan and publish it. And I would really encourage us that as good practice for just good clinical practice or good research practice, it's always a good idea to publish your protocol. So you can go to clinicaltrials.gov and publish your protocol. You can also encourage your students, if you're supervising masters or PhD students, to publish their protocol along with their PSAP, both the protocol and the statistical analysis plan, so that they develop that culture of doing research the right way. So that that avoids you just moving the goalposts. And then when you don't get the results you had in mind, well, just simply manufacture the next set of results that will suit your narrative. That's not a good thing, obviously.
Thank you, Prof. Someone still doesn't understand overlapping from the data.
So, well, somebody else should explain it to them. Or they can also watch the video.
So, Prof, if you're using two states, like she asked, are you calculating the sample size separately?
No, you're not calculating the sample size separately. So here are two scenarios. Scenario number one, you want to just use two states. Maybe your budget allows you to only go to two states, but you want to use, but you want to make inferences for the whole country. But you can't make inferences from two states to the whole country, right? Why? Because if you're using the two states as clusters, that doesn't make sense. Let's go back to the suppression rules. For example, the suppression rules from NCHS says that you need to have degrees of freedom of more than 8. The degrees of freedom is simply equal to the number of clusters minus the number of strata. So in your study, if you are using the states as clusters, well, it means you only have two degrees of freedom of 2, right? Your study is dead on arrival. So instead of you trying to use states as clusters, you should use states as your population. So don't worry about trying to generalize to all of Nigeria. Redesign your study so you generalize to only those two states. Then within those 2 states, you can then select clusters, which could be local government areas, or could be schools. So if you're selecting 2 local government areas in the 2 states, well, then you have way more than 2 to select from, right? You could select like 20 local governments, right? In which case, the degrees of freedom is way more than 8. So the bottom line is no, you don't have to calculate sample size for the different states. I think what's confusing you is that you're thinking my population is 2 states. No, your population is 1. You have 1 population that is made up of two states. That is not the same thing as having two populations. It's one population that is defined as two states.
Right, thanks. Those who still have their hands up, I just want to make sure if those are new hands because you have asked questions earlier. Ibekele, Samson, Faraja. Just want to make sure if you still have a question, you can keep your hand up. If not, please lower your hands. Okay. After calculating sample size, how do I determine the number of questionnaires per state? Should it be equal number?
The number of questions in the state, that's up to you. There's some questions that are up to you as the researcher that nobody can answer for you. It's based on your context. So we can't answer that question for you, unfortunately. It's your question to answer. But in general, the principles you want to consider is, one, don't overwhelm the audience. Don't ask people 1 million questions, right? Because that directly has an impact on the quality of data you're going to get. Number two, if the study is one population, remember we said your study is one population that is made up of two states, then you want to make sure you're going to compare apples to apples. If you're going to ask one group a different set of questions and another one a different set of questions, well, that means that you don't have one population, then you have two different populations. So think of populations, not states. Like, what is the population? Conceptually, what is the population? So don't worry so much about issues of states. Think of one population and then think of one instrument. One population, one instrument, one study, one everything.
Thanks, Prof. Okay, before I come back here, I'm going to read one more question from YouTube. Is there any way we can calculate sample size in chi-square platform if I am using a secondary data?
So why would you want to calculate sample size when you already have secondary data? So the answer is it does not make sense to do so. Sample size is saying this is the number of people I'm going to need. But here you already have a fixed sample size. What you should do is to say, with this sample size, how much precision do I expect? Right? How wide do I expect the confidence intervals to be? Right? So that is what you want to do instead. And a backhand way of doing that is to say, let me show you. So we'll go back to the survey, percentage outcome, and you can estimate it indirectly, the precision, by saying, okay, let's say the sample size I have is 1,726, 1,727. That's the number of people in your sample size, right? Let's say that the second data set you have you can even put a response rate of 100 here because it's secondary, right? Just give me a second. We see what I'm saying in a minute. So let's say we have this here. That's a ridiculous, assumption. So let me do something that's more realistic. So we have prevalence, sorry, wrong field, 50 as a prevalence. What I was trying to show was what response rate of 100, since you already have everybody in the survey. So now let's say that this is what you have. You have your second data set, you have 385. The response rate is 100%, obviously, because you're not going to the field to ask people. It's a fixed number of people you have. So the point I'm trying to make is that it is futile or completely useless saying I'm going to see how many people I need. A more interesting question is, with this number of people that I have, how wide do I expect the confidence intervals to be? That's a more interesting question. So in this case, I can say, oh, well, I can expect that with the sample size of 385, I'm going to have my confidence interval is going to be 10 percentage points across. Because remember that the confidence interval is 2 times the margin of error. So the margin of error here, just multiply it by 2, and that will give you the width of your confidence interval. So in that kind of context, that would be a more interesting thing to ask, that given this fixed sample size, how wide will I expect the confidence intervals to be? Next question, please.
Thanks, Prof. Alassane. Please unmute yourself.
Thank you so much, dear Prof, for giving me the floor. My name is Kosube Alassane. I am from Burkina Faso. Please, my question is that I want to know the difference between standard deviation and standard error. I haven't understood more it.
Okay. Let's put it this way. The two key differences. Let me go back to the slides. The standard deviation is talking about when we're comparing individuals. So we're saying that how far on average, right, does each individual fall from the sample mean? That's what we're saying. That's what the standard deviation. So we now average all of those distances. That gives us standard deviation. The standard error has to do with sampling. When we're sampling entire populations. Conceptually, that's a key difference. Now, we also see a difference between the two of them in how they are impacted by increasing sample size. The standard deviation is more or less fixed. Yeah, the standard deviation is an inherent property of a variable. It doesn't change with sample size. The standard error would become less and less the more people are in the study. Think of it like your tooth, the human tooth. The same size of your teeth when you were 6 years is the same size now. The tooth size doesn't change. It stays with you fixed forever and ever and ever because it's an inherent property that you have. But other parts of the body might become smaller and smaller with age. Think of the bones, for example. Your jawbone might become smaller because, of course, it becomes more brittle and as resorption occurs. Sorry, I'm turning this class into a physiology class, right? But the point I'm trying to make is that that just illustrates fundamentally how one is fixed regardless of sample size, but the other one decreases with sample size. So you expect that the error, standard error, that's what we said earlier here, if I can find the slide, that you can make the confidence intervals tighter by increasing the sample size. Because when we increase sample size, we reduce the error with which we're measuring things, and that makes the confidence intervals narrower. So I hope that is clear enough.
Thanks, Prof. Does one still need non-response rates for a cross-sectional study where one will be able to replace those who do not respond to reach the minimum sample size?
So first of all, you want to be very, very careful with replacing people, right? That makes your survey non-probabilistic. So you want to be very, very, very careful. I know that's not the question you asked, but that's a more interesting question and that has significant impact on validity. Let's say you have a large survey and you have probabilistically selected individuals, right? And so you go to this first guy, he's not around, he's like, okay, I'll just take his neighbor. Well, at the end of the day, you end up with a sample that is just folks who are staying at home. That's no longer a random sample. That is a very biased sample, right? This is why in national surveys, we go back to that same house over and over and over. Once this algorithm said that you are in our survey, we can go to your house 100 times till we find you. Now, if we don't find you, we just declare that that's non-response, right? And that's where we now have to worry about weights. This is where weights come in. We now look at, okay, there were differential response patterns, and we have to adjust for them with weight. Well, let me go back to your question now. Your question was, okay, what if I just want to replace those people who are not there? Do I have to worry about response rate? Well, in that case, then, your study is not probabilistic anyway, so you can do whatever you want. You can ignore response rates, you can do anything, because at that point, once you start replacing, it's no longer probabilistic. So you can do anything you want, really. So we really need to understand the context in which these things work, because a small difference in how we implement things will completely change our study from a probabilistic design to non-probabilistic.
Thanks, Prof. Ibekele?
Yeah, thank you, sir. I appreciate all of this clear information. So I want to ask a question. In a case whereby I'm trying to confine my finding to the sample. For instance, I just want to evaluate the prevalence of a certain event or disease among participants of all of us research. So do I still need to estimate with confidence interval, since I'm not going to make inference to the public, knowing fully that it is not a probabilistic sample? Thank you.
Yeah, so like we said, if it's not a probability-based sample, there's no mathematical basis for generating sampling errors and then standard errors. So you should not even report it with confidence intervals. You should just report percentages, and that's it. That's fine. The same thing applies when you're using the census. When you take a full census, we also don't report confidence intervals. You just report the percentages. I think people are used to reporting confidence intervals so much that they think there's a knee-jerk reaction to just reporting them. But it's extremely important that if we're going to be good researchers, we need to know the context in which to do certain things and the context in which that same thing is wrong, right? So that it's not just one brush paint, we're painting everything. Of course, the software will output that for you every single time, but it's your job to know that, no, this doesn't make sense in this context.
Thank you. Samson?
Thank you very much, Prof. You indicated that once data is weighted, you compare with the population. My question is, how do we do the weighting? And then when and why do we do the weighting?
Okay, so let me answer the why first. This is our sample. This is the population. These two guys do not look like each other at all. So when we generate an estimate from here and we say, oh, we cannot even attempt to apply estimates from here to here, because these are apples to oranges. So the question is, what do we do then? Right? Like the scenario that the other person asked before, where they said, well, I'm trying to do a national survey and I keep going to this house and the guy is never around. So at the end of the day, after going to his place 100 times, I just have to leave him because I have to go on with my life, right? I can't just keep going to his house forever and ever. Now it's not just that one guy. There are a whole lot of other people like that who end up not responding to our survey. And maybe those people who don't respond are people who are, maybe they are males, or maybe they are students who are off to college, right? Or they are just people who have very long jobs, who do very long hours. So that means that our sample now is beginning to look like this. It's no longer like the population. It's very skewed. So the question is, but we still want to use the samples to make inferences, right? So how do we do that? Well, we have to weight the data. Weighting data, what the weighting does is that weighting forces the sample that looks like this, it forces it to look like the population. And we have changed this. So what weighting does is weighting creates this new guy here by forcing our sample to look like the population in all those variables that we have selected. All right. Now, of course, you're not doing that manually. The Chisquares platform does that for you automatically. So that in case you wanted to weight your data, if you're selecting, let's say your weighted data, so let's say this is the survey we want to weight. You come to, under data access, there's weight data here, right? So you select the variable. Now, right at the beginning, of course, there are no weights calibrated. So you'll have to select the variables you want to weight data on, right? Computationally, weighting is one of the most complex things you can ever do, but the way it has been implemented on the Chisquares platform, even the baby can create weights, right? So you click on create new calibration weights, and you select the variables you want to weight on. You give the weight variable. So what essentially is going to do is that it's going to create a new variable in your data set, right? You select the variables you want to weight on. Let's say you want to weight on age, sex, race, and a whole bunch of other variables. For each variable you select, obviously these are just this is an evaluation course, so it doesn't have any good variables, but we just go along with it. So let's say we want to weight on this variable, and let's say this one variable, right? So these are the categories in our data set. We now have to provide the percentage of people in the population that report these same categories. So what percentage of the population report being just right? Just pretend that this is male, female, whatever. So we have to provide the corresponding percentages in our population, right? And of course, they must equal to 100%. And we'll do that for the next variable and the next variable, right? It is on that basis that, we apply a statistical procedure called raking, right? Raking, in a nutshell, what it does is that it takes the first variable, forces the sample to resemble the population on that variable, then it takes the next one and applies it to the weighted one. And that's why it's the technical term for raking is called iterative proportional fitting. Iterative because it's being done over and over and over. Proportional because it is, the whole idea is to make the sample to have the same proportion of people on each characteristics like the population does. And fitting because it's a model. What we're actually doing now is we are creating a mathematical model where we are simulating reality. So that what we create here is what we call a pseudo population. It does not really exist, but it exists for statistical purposes so that we can describe the population. So long story short, that's what weighting does. It's just a way to force the sample. And this is what news agencies do all the time. If you read the New York Times or Washington Post, they'll tell you, 50% of Americans support this. But you should realize that they are getting their samples from web surveys or web banners. They're not national representatives. So what they do is they get that and then they apply raking to force the sample to become representative nationally. And that is on that basis that they can now say 50% of Americans support this. Not 50% of people who took the survey. Because once you weight the data, it is now representative across the, of course, with limitation. It's not perfectly representative because even look at this shape, it's not exactly like this, but it kind of looks like it. And for practical purposes, we can use it to describe the population.
Thank you, Prof. Why are we not using the percentage estimates for eyeballing significant tests?
Because the estimate cannot, the estimate doesn't tell you anything. The estimate tells, remember that the question we're essentially trying to ask is, does this come from the same population as the other one? Do those two come from the same population? The only way we can tell that is with confidence intervals, not the estimates. So they serve different purposes. That's why we cannot use it.
Thank you. Thanks for the enlightenment, Prof. In climate change and disaster risks research like flooding, can I use previous flooding data and experiences to infer future risks?
Well, you should also know that you can infer all you want, but it's just a guesswork, right? All mathematical models are wrong. So that's the premise we must start from. All are wrong. Then some are useful. So when you keep that in mind, that keeps you from making false generalizations from the data, because you know that this is not data. This is just an educated guess. Like the only difference between us and the guy who is sitting at the bar and making a lot of, loud talk is that we are doing it on the computer, all right? And we're using some fancy software. But that's exactly how you must think of modeling. Like modeling is just a guess, right? We try to make it fancy and put a lot of technology, but that is why wherever you can and whenever you can, use the data. 100 times out of 100 times, you should use data when you have access to it. I suspect that there's something about modeling that sounds fancy that people want to do it, even when they have data. I'm like, that doesn't make any sense. Why are you not using data? That is what you should do because the whole point of using models is that we don't have data. So when you have data, sure, use it. Now, when you don't, well, we have to say something. We can use models.
Right. Faraja.
Yes. Can you hear me, please?
Yeah, we can hear you clearly.
Yes, so thank you, Prof, for this brilliant presentation. So my question is that how practically, what you have been saying about these tobacco results previously, we have seen that we do have the above and the lower CI figures. So for me, I was thinking that these were drawn from a benchmark study that has been done in the US, and then for the newly performed survey, then we had to compare the results that we have got to this benchmark study that has been done previously. But I didn't see what you said about it, because we didn't compare, we didn't say that these results were being compared to the benchmark studies to see what do we have the results for our estimates, and we compare to these intervals, CI intervals we have seen from the benchmark study that has been done previously for the US, so that we can compare. So my question is this: how do we practically perform, the determination of these lower and above, lower and upper limits for these CI intervals? Once we have to, if we need to perform it for our study, how do we perform it? How do we get to know this will be my lower CI interval, and this will be my upper CI interval? So this is my question, please.
Okay.
I think 2 points for this year. 2 points.
So
The benchmark study was done or not, and also how to determine the lower and upper CI intervals.
Okay. So the previous study that was done is also a sample, and the one before it was also a sample. So they're all samples, right? So we can't benchmark a sample and another sample. And here's the dilemma. We don't actually know what the parameter is. Remember, in our illustration, you can't just go in and see the president, right? So you are always seeing the chief of staff. So you can never know what the president will ever say. This is the paradox we are in. So that's why we resort to using, statistics to give us a sense of what that is. Now, your question is, how then do we calculate the confidence interval? Well, we don't calculate it manually. So first of all, let me get that very clear. We're not sitting down and saying, here is the confidence interval. No, it's software. And we're going to have a feature session that's going to be hands-on, where we're going to calculate those things live. You can see them with your 2 eyes. You can also do it in practice, right? In real time. So make sure you follow us, and you can attend that session to get clarity. So I think that's the best way to do it. When we have the session, you'll see it. But what we are doing is we are not calculating it by hand, right? Now, philosophically, what is going on behind the scenes? Let's ask ourselves that. So philosophically, what's happening is that we have one sample. We drew only one sample. But statistically, what we're trying to do is we're saying, what if we had taken 1 million samples, right? How far, what variation will we get from each sample relative to the other, right? So this is what we're trying to say. We're saying we can find a way of mathematically estimating what we think the population parameter is. So if we took 1 million, fine, we took only one sample. Keep that in mind. But what if we assume hypothetically that we took 1 million samples? How far will each sample fall from the population parameter? And then we can now from there get a sense of what that would be, right? This is very similar to what we do when we do what we call bootstrapping. Bootstrapping is a way of calculating confidence intervals by hand. Well, I don't mean like by hand, literally, but there are certain statistical procedures that don't give you confidence intervals by default. And that's one of the things I would recommend should be in your toolkit as a researcher, right? The ability to generate bootstrap confidence intervals. And all you're doing in that case is you have a sample of, let's say, 1,000 people, and you're sampling with replacement. So you sample, let's say, 800 people from this 1,000 people, and then you sample another 800 with replacement. As you're sampling, you're replacing, right? That allows you to get an infinitely large number of independent samples drawn from that same sample, right? Bootstrapping simply means, pulling yourself up by your feet by yourself. Like it's like, a poor man trying to walk his way through. So the idea is that, well, we have one sample, but we need to do something. So, well, we don't have a lot of resources. We're just going to use this one sample to do all we need to do. So bottom line, we use software. And so when we have our next session on that, you should definitely make yourself available.
Thanks,
All right,
Prof.
next question.
Is there a formula starting relationship between sample size and power test?
What was the question?
Is there a formula starting relationship between sample size and power test?
That question doesn't make a lot of sense from a so sample size calculation is a broad term that applies to how many people do we need. Power calculation is also sample size. The only thing that power calculation is sample size calculation for analytic studies or comparative studies, right? So power calculation is a subset of sample size calculation, which could be sample size for descriptive studies. It could be sample size based on cost estimates. It could be sample size based on precision. And then we have, obviously, sample size for analytic studies, which is also called power analysis. So what your question is saying, what's the formula that connects sample size and power? It's like, so that's why it doesn't, the question is there's none, because the question can't be answered. It doesn't make sense in that context.
Thanks. Is the statistical analysis plan the same as research methodology?
No. The research methodology is a very broad term that you should have research methodology in your protocol. And now, in general, I'm never a fan of semantics, right? So whatever you call it is fine. What we want is that you create a plan that shows how you're going to analyze the data in detail. Now, whether you're going to call it methodology or whatever you call it, that is completely fine, as far as you understand what is required and why we're requiring it. The reason why we're requiring it is so that you don't move the goalpost, right? But in general, a methodology is like saying how we're going to do it, right? Which could be anything. It could be methodology for collection of data. It could be methodology for recruitment. It could be methodology for anything. Statistical analysis plan is specifically statistical methodology. So you can think of a statistical analysis plan as a smaller subset of just your overall study methodology. It includes specifically how you're going to analyze data as a small component of all of your overall methodology. But again, semantics don't matter. As far as you understand what we're trying to say, that's fine. You can call it whatever you want.
Thank you, Prof. Abdu, oh, have you lowered your hand now? Let's see. Okay. Dr. Abdullahi. Dr. Abd, okay. We can't hear you. All right. We'll move to Eze.
Thank you, Prof, for the enlightening lecture. I really enjoyed it. For the basic science researchers who may use animal models for their study, I want to know, is there a way to calculate the total number of animals, say oyster rats or mice, that may be enough for their study? Thank you.
That's a great question. Sample size is also agnostic of the population itself, the kind of population. So I could be doing a survey where I'm looking at human beings, or I'm looking at appliances. What percentage of manufactured appliances are defective, or rats? It doesn't matter. The sample size, the principle is still the same. It boils down to how many people do I need to get this degree of precision, or how many people do I need to get this degree of power? Same principle.
Thank you, sir.
You're welcome.
Coyote. Right. Dr. Abdullahi.
Thank you very much. Thank you very much, Prof, for this insightful lecture. I still have one or two areas I need your clarification. One of them was where you mentioned there was an acronym you mentioned, I think, SINS Pro, skipping ineffective. I didn't really get how you explained that acronym. The another acronym was the PSAP you mentioned. Yes, and then my second question is regarding the precision and the validity. Those values, how did we come about those values? Are they also computer generated, or are they arbitrary values that are set in research? Thank you.
Okay, so let me start with the last question. These numbers, I just wrote them. These are just random numbers I just wrote for illustration purposes. So if you're referring to this one, I just typed some random numbers. Now, the other ones here, obviously, are generated by software. And we're going to have a session that will show you how to do that. Then, the PSAP. PSAP is just a term that stands for Protocol and Statistical Analysis Plan. So we're all very familiar with writing protocols, but ideally, we want to pair those two together. So that's why it's P-SAP, Protocol and Statistical Analysis Plan, as one combined document, or and then the other one was about the simple framework, like not all missing values are the same. So like when you use the Chisquares platform, for example, and let me show you how that is implemented here. So let's say we downloaded data here. Let me download this data. So when you're downloading data here, you have the option to download either the clean data set or the raw data set, right? The clean data set is automatically clean for you to use as you desire. But for those who want to suffer, you can just download the raw data set and suffer with it. That's your prerogative too. So let's download the clean data set so you can see what we're referring to. All right, so that has been downloaded. Let me grab that up. So it's loading up. Let me share this. So I'm using two screens, so it becomes, let me share this screen one. Okay, can you see the file here now?
Yes, Prof.
All right, great. So so this is the clean data set that has been downloaded. There's also, of course, there's a code book. So for each variable, you also have an indication for the platform tracks the kind of missing value you have. So let's focus on just this column. For example, let me highlight it so that we can follow through accordingly. So here, for example, you see that this individual has a missing value, and you see the value. Let me make this bigger. So this is for each variable that has missing value, the platform automatically creates a column that tells you how they got missing. right? Because the individual is taking the survey, the platform tracks for each individual, whether they were just not eligible, whether they were eligible but somehow missed it. So here this person tells me that this is no response. This guy came, they saw this question, they just skipped it and said, I'm not going to answer this question. So that helps me to know that, okay, this is non-response. The way I'm going to handle non-response in my analysis is quite different from how I'm going to handle, let's say, someone who's not eligible, right? This one too is non-response. This one, again, he came here and he chose to skip the question right away. This is different from this guy here. P is partial complete. This guy never got to this point in the survey, right? So if I'm trying to assess data quality issues, I'm trying to see why do people not, like I can do a lot more to the data. So you don't just treat all missing values as the same because they're not the same. Somebody who is not eligible for the survey and skipped is quite different from an individual who was eligible but chose not to answer it, right? So so the Chisquares platform applies this framework so that it's not that you collect the data and then you start wondering, I wonder how these missing values were acquired, like how did this get missing? Well, you don't have to ask that question because the platform automatically captures all of those things for you so that you can better address issues of missing values. I hope that answers your question.
Yes, sir. Yes, so I get the skipped and the other components you in that acronym.
So the skipped is if you have a skip pattern, right? So let's say you say that, let me go back to the other screen. Share. Stop 2. So let's say that our survey has a skip pattern. So let's go back to the survey we were doing initially. And I think this was I think I was using Longilate survey platform. Let me use this. Okay, great. So this, let's go to the survey we had, if I can find it. Sort by created dates. Okay, good. So skip pattern is when you want some people to be skipped from certain questions. Please don't ever conduct a survey where you're telling people by instruction that please don't answer this question if you don't belong to so and so category. First of all, nobody reads instructions. Like, you're going to end up with so poor quality data that it makes no sense. So you have to define inclusion criteria, right? Let's say that our study has our inclusion criteria for our study is that you have to be in your 4th year or your postgraduate, right? That's our requirement. It will be silly for us to now start saying, please only answer this question if you are in your 4th year or postgraduate or higher. No, we can set up criteria. So in this case, we come to logic and set up inclusion criteria. Inclusion criteria determines who can participate in the survey, right? So we set up our criteria and we base it on this question. I would say, include participants if this is containing any of, they are in the 4th year or postgraduate or higher, right? And we submit the criteria. So now this is just telling us that the platform is saying this is what it's going to show to people at the beginning of the survey, if they are so that they can be aware that it's a screener. If we want it, we can save and include. Here it's telling us this is what it's going to show to people who are not eligible. And you can edit any of these things if you want. We save and include. And then lastly, for people who are eligible, this is what's going to show them, right? So now we have set up the inclusion criteria for a study, which is if this is containing 4th year or postgraduate or higher. So what does that mean? It means that when we're taking our survey, let's preview it, for example. When we start taking our survey, we see the preview that tells us that there's a screener question. We go to next. What is your current educational enrollment status? High school or high or lower, you are not eligible to participate, right? The platform has assessed that, no, this person is not eligible. Now, in the data set, what they're going to get is I for ineligible, because all the questions that came from question, because this person only answered this question, right? All these other questions are missing values. But we are able to know automatically because they will carry a value of I for ineligible, right? Yeah, it's a different thing from this other guy who, let's say, he's start the survey, and so 4th year college, you are eligible because you have met the inclusion criteria, and we could proceed on next, right? Now, let's say that we want to, in our design, we want people who have said that before today, have you ever heard of ChatGPT? If you have not heard of it, well, then you should not participate in the study, because even though you are eligible, the goal of the study is to say, compare people who are using ChatGPT versus those who are not who are aware of it but not using it, right? Let's say that that's our hypothesis. So we want to say everybody who answers no or not sure should be skipped to the end of the survey, right? So we can implement a skip pattern. So in that case, we come back to logic and come to skip patterns and set up skip patterns that say we're going to use this variable and says if this variable, the value is any of, you either said no or you said not sure, then the question is, where should we take you? Should we take you to a particular question or should we take you to the end of a survey? Well, in this case, we're going to take you to the end of the survey and, and say thank you. So that's the idea here. And then we can submit such that those individuals, once they come to the survey and answer those questions, the platform takes them automatically to the end of the survey. That means that such individuals did not answer the questions that were in the middle here. The value they will get for those variables will be an S, meaning that they were skipped. Not that they were not eligible, they were eligible, but for whatever reason, we wanted to skip them. So whenever you are putting instructions to people and telling them, hey, please only answer this question if you are in this place, you have already failed, because you're going to get very poor quality data. The way to address that is with, survey logic. And on the Chisquares platform, it's so easy to set up. All you're doing is just click a few things, select, and that's it. And the platform will enforce the rules. I hope that answers your question. All right, next question.
Hope so too. Coyote.
Thank you very much. Prof, it's a great job you're doing. I'm very grateful for this. I'm learning a lot. And thank you, Madam Moderator, for the second chance. I'm a pharmacist and I'm doing a research on a technology. That's a mobile authentication service that's used to authenticate whether a medicine is genuine or not. Whether it's from the real manufacturer that's indicated on the label. Now, I'm using, my study design is explorative sequential mixed method, but my worry now is that I did the qualitative first because I've not found in literature where where research is done on this same mobile authentication service, where anybody is talking about how the technology got to be on the pack before it's being used. So for me to be able to ask the relevant questions, I did the qualitative first to get to the bottom of how the technology started to be on the pack before it's been authenticated. So my mixed method is not like I'm starting with quantitative and then looking for means of explaining it with qualitative. I did the reverse, whether that is okay or not. And the second thing is I've collected all my data, I've finished analyzing. I'm now seeing that why don't I do some, qualitative analysis of the medicines themselves, which is laboratory work. So now, how do I now describe my study? My study design. Now I can't just leave it at explorative sequential mixed method anymore because now there's lab content of it. So how do I describe it? Plus whether it is right to start with qualitative like I did before quantitative. Thank you.
Yeah, thanks. So Yeah, you can start any sequence you want. Qualitative can come before quantitative, in which case we call it formative research. The whole idea behind formative research is that it, as the name implies, it forms what we do, or it formulates what we do in quantitative. And this is, in fact, that's the most common way we execute when we do large surveys. We do a small scale stuff that helps us to know what things to add in our questionnaire. Because doing a large survey is expensive. We spend millions of dollars on each survey. Obviously, you don't want to just take that kind of money and just go and execute a survey where you don't even know the lay of the land. So we try and know the lay of the land first through qualitative formative research, where we see, okay, how do we measure these things? And, we have focus groups and we do all of that. And then based on the insights we get, we then go ahead. But in general, right, we really just want to stay away from classifying things as right or wrong. It's just, it's more appropriate, classifying it that is it relevant or not relevant in my context. That's a better way to look at things. Now, for the study design, for the second part of it, you can. It doesn't really matter so much what you call it. You can call it a laboratory study. You can call it whatever. What we call things doesn't really matter so much in the grand scheme of things. What will matter more is a clear description of the laboratory methods used. Are there benchmarks? Are you, what reference standards are you using? How sensitive are the equipment, and all of those things, right? Those will be more appropriate in that context to this. So I'll worry more about those things than just any descriptor of the methodology itself. All right, next question, please. Oh, we have answered all the questions, I believe.
I wish. Let me just read the last one from YouTube.
Okay.
Prof, is there any textbook you would recommend for better understanding of all these salient points contained in your explanations?
So the thing is, I don't know of any one textbook that you would have to read to understand, because it's unfortunately, the way textbooks are structured is that you have a textbook for statistics, and a textbook for epidemiology, and a textbook for so it's like you have to really read a whole lot of things. But I worry less about textbooks. What I really worry about is how do you gain hands-on experience, and the only way to do that is to just do. Got to do it over and over and over, and you have to make mistakes, and you have to be comfortable with making mistakes, and get comfortable with being uncomfortable. So that will be more, that kind of experiential learning will be more, I think, more helpful to you than, and just also come to our seminars. We try to, we're also going to be doing a lot of deeper, more hands-on methodologies in this coming year. So you really want to make sure that you follow us so that you get announcements when those happen.
Right. Someone posted this question so many times. Let me just ask, how do I calculate my sample size when my data to be collected is agronomic data, quantitative?
The sample size method, sample size is agnostic of your field or whatever. We've answered that same version of that question a million times. So it doesn't matter what your field is. What you should worry about is, number one, what is my population? And number two, is there inherent clause? What's the unit of analysis, right? That's a very important question. Like the question that Hayuri had asked earlier about pharmacies. So in this case, the unit of analysis is actually the drug, but he's not going to go and speak to the drug individually. He's going to the pharmacist first. He goes to the pharmacy, even though the unit of analysis is not the pharmacy, but the drug. So in that case, the pharmacy is a cluster. So you already have your clusters defined as pharmacies. So in that kind of case, that's like a two-stage cluster design where you're selecting a random sample of pharmacies. And in those pharmacies, you're selecting a random sample of drugs. That gives you a two-stage cluster sample design, right? So those are the more interesting questions that you need to be asking about your design. Like inherently, what is the unit of analysis? And what is the unit of sampling? And how am I getting from a unit of sampling to the unit of analysis? And how many steps will that involve, right? And so those will be the issues that will ultimately decide what the sample size will be. Because in that case, then when you're doing your sample size on the platform, you will know that you have to supply. So let's say this is a cross-sectional study, and you obviously know that you're going to use cluster sampling because the medications you are trying to access are not just standing in their own, floating in space. They are nested within pharmacies. So that means that you will be using cluster sampling. So you need to understand those things so that it's not just about clicking things and getting results. You really understand what's going on, and you can modify things as necessary.
Thank you, Prof. Prof, my question is on the issue of research translation about don't extrapolate. In a situation where I review certain literatures on a prevalence rate over time, can I use that to state the based on the prevalence over time, the prevalence remain a significant health problem even in future?
Why are you speaking in the future? Are you in the future? Or is it not enough to just say that it's a, must it be a health problem? Must it be a problem in the future? Is it not enough that it's a problem now? Like, don't you have enough problems already? It's like we want to create more problems for the future. The ones now are not enough. So my point is that the problems for the current now are enough problems that we have to deal with, that we don't have to worry about creating problems for the future. But if you really, really want to frame that, you can still say it, right? You can still say, current data suggests that, but you also want to be very careful with the language you use. You can't say will be a problem. You can only say the data suggests, or we can infer from the data that if it is not addressed, this will be a problem, in the future, right? Because we end up coming up with all this model. So this is, I work a lot in infectious disease outbreaks, and we always come up with those fantastic models which end up like let me show you an example. Let me see if I can find this Ebola predictions, MWR. So in general, see, we always love this future thing. Estimating the future number of cases, we never ever learn. And it's always very funny because we're always so far by miles, not even remotely close. But we never learn, right? I think there's something about mathematical models that people just find very sexy. So it's like we just feel a need to do it. But here, for example, we estimate that we're going to have millions. I can't remember how many millions of cases we said we're going to end, but we end up far short of that. And then we have to start saying, well, this is what happened. If this had not happened, this is what will have happened. And like, moral of the story, just stick to the present, okay? We have enough problems in the present that we don't have to worry about, and there's still data needs for the present. We cannot solve problems for the future. We can just at best solve problems for now. So I think that as researchers, there's something to be said about modesty. Modesty means acknowledging our limitations. We don't know tomorrow, right? We barely can tell what's going to happen to us as individuals tomorrow. Talk less of talking about what's going to happen to a whole country tomorrow. That goes a little beyond our ability as humans. So my encouragement with let's just stay in the present and talk about current. We have enough problems to discuss at the present, so let's do that. But if you must talk about the future, you should hedge it very carefully that this is a suggestion, not that it carries the weight of gold.
Thanks, Prof. Is it feasible to take more sample size than minimum required sample size of a study? If one increases a sample size more and more, does this will change estimate value of the effect being studied?
So remember, sample size has no impact on validity. So let's understand that. Your sample size does not impact the validity. So that second part of your question is answered by that premise. the first part of the question is, can you take more and more? Yes, but should you, like, why should you do so? Why, what's the reason, right? And that's what any good ethical board should ask you. If the sample size needed based on a reasonable calculation is 900, and you say I want to take 9,000, any good ethical review board should say, so you just want to subject 8,000 extra people to the harms of a study, because every study has its harms. We have to acknowledge that. Every study has harms. They may be small or trivial, but they are still harms. Even if it's just wasting people's time, that's still a harm, right? So you just want to subject people to 8,000 excess people to the harms of your study. For what reason, right? So that ethical consideration should be something we think about, but also the logistics, because every study also has costs, right? The cost to us running that study. We need to consider those things carefully. The issues of cost to us and the ethical concerns for the participants. Those should be a rate limiting step in preventing us from just recruiting more and more and more people way beyond what number we actually need to answer the research question.
Thanks, Prof. Is it good to do a comparison analysis with socio-demographic values when you only have an independent variable and dependent variable?
I'm not sure what this question is getting at. The person can clarify themselves, because I mean, I heard what they said, but the premise, the scientific premise is a bit missing. So maybe you can frame it as, what are you trying to achieve exactly?
So you've heard and okay, sorry.
But let me just answer the spirit behind the question. So you have a dependent variable, right, which is your outcome, and you have an independent variable, which is a predictor. And then you have a whole bunch of other variables. The simple rule of analysis, of selection of variables for analysis, is include all confounders and exclude all collinears. The collinear variable is a variable that's associated with exposure, but it's not associated with the outcome. Confounders are variables that are associated with both exposure and the outcome and do not lie on the causal pathway, right? The way we can detect confounders is through, statistical tests, as well as through our subject matter expertise. So we cannot just say we want to measure the relationship between exposure and outcome when we have not controlled for confounders. Because remember, we said everything in the universe can be explained by one of three things: truth, chance, and bias. In this case, our results will be affected by both bias and chance, right? So we want to make sure that we control for alternative explanations. And so we'll need to figure those out. So I think that addresses the heart of the question, or what I think the person is trying to ask, that if they're still unclarified, they can ask further.
Okay, I think that was the last question.
Oh, that is
Charles
that's
is
the number
asking.
of. Okay, no, go ahead.
Prof, you promised to share data sets to support interested folks publish papers, though not in this class. I really need some data to analyze and publish.
Okay, we've not forgotten. We're trying to package in a way that it will have the greatest impact. So we'll share that very soon. But thanks for the reminder.
Good evening,
right.
Prof. Please, I am to do a retrospective review of data within the last year. For example, do I still have to calculate sample size, or is it okay to include all records that meet the inclusion criteria?
Sometimes you have no choice. Sometimes it is what it is. Sometimes you are doing a study where the population is so narrow that you just have to take whatever you can get. It all depends on context. If it's a, let's say you're in a hospital and you're doing a chat review. Well, most times it's especially for a rare outcome, well, you just have to do everything. You may just have to take everything you can, right? But knowing fully well that the analysis will just have to be just descriptive. But if you are doing it, let's say because a retrospective study could also be a retrospective cohort study, in which case you will now have to formally calculate sample sizes and ensure that you have enough people to detect differences between the exposed and the non-exposed, even though it's retrospective.
Thank you. Oh, wow, more questions. Wow. In the eyeball, why did we not use the percentage estimates to check for significance?
Because the estimate doesn't tell us anything about the population where it comes from. Remember, the estimate, the goal is to try and see, are these two statements, the confidence interval tells us, are these two statements coming from the same person, right? We compare the degree of, we're not interested in this, we're not interested in whatever the secretary said at this point. That's a moot point. We're interested in what the president had, what we think the president had said. So it's like you have two statements and you're trying to compare, both of them are from the president, allegedly, right? You're trying to compare these two things from his president. The secretary is out of the picture at this point, because whatever he said is immaterial. It's what the president said that we're interested in. The confidence interval represents the measure of certainty that the president said something, right? So that's why we're not using the point estimate, because the point estimate has nothing to do with our degree of certainty. The confidence interval is what does that job. It tells us how much certainty do we have that this is from this population. So the question is, are these two people from the same population, right? So if they are from the same population, that means they're very similar, so there's no difference. If they're not from the same population, they're going to be different. So we're going to say they are different from each other. So that's why we're not using the point estimates.
Are you reading that question, Prof?
Yeah. So what I mean is I can use socio-demographic variables like age to determine my outcome. So you should not socio-demographic variable. So the issue on hand is, how should we determine what our outcome is? Is the outcome determined by the data, or should we come with the outcome in mind? So you should know what the outcome is. You're not relying on any variable telling you that this is your outcome. Your outcome should come from your mind. So that's the simple answer there, right? Your answer comes from your mind. You say, okay, this is what I'm coming to research. This is why you must have a hypothesis before you even look at data, right? So you have a hypothesis in mind. You're saying that, women who attend so-and-so salon have whatever, right? The outcome comes from your mind. The outcome is driven by your biases and what you think and your feelings. That's what drives your selection of an outcome, not that other variables telling you, because you're the one running the show, not the variables running the show. So the variables are not the ones telling you what to do. You decide what to do. This is my outcome, and then you investigate accordingly. All right, I think we've answered that question. And any other questions from now will be answered by Lungile.
Any other question from now will be answered next week by Prof. Agaku.
That is so funny.
Veronica is not giving up. She's like, hey, you're
Okay,
not
let's
leaving.
answer. All right, let's
Not
answer
answering my question.
That's fine. Let's answer that question. Veronica, what's your question?
Yeah, Veronica. Please unmute.
Okay, Prof, please. I'm trying to use a chi-squared platform to calculate sample size, but the cross-sectional study option is not highlighted for me to click. So I'm stuck.
Are you sure it's your browser? Or just refresh the page, or maybe, it could be your browser.
Okay, Prof. Okay, Prof. Thank you, Prof.
Right. You're welcome. All right, Lungile, I'll leave you to take the remaining questions. Thanks, everyone. And
how about I leave you to take care of any other questions?
That's funny. Well, enjoy the rest of your weekend. Thanks, everyone. Bye.
Thank you, Prof. Bye. Yeah. Thank you, everyone.